This is Josh White with JW Math Tutoring. Do you want 50 of the hardest digital SAT math problems from 2024 to practice with? Then go ahead and watch this video.
But life is a dream the calculus could never predict.
Looking at this first problem here, you're basically given 3 points, and these 3 points are essentially forming an angle on the unit circle. You have F here at 1, 0. You have G here at the origin, and then H is negative 1 something. So, basically, I guess it theoretically could be up here, could be right here at negative 1, 0, or it could be, down here, negative 1, another Y value in the negatives. However, the shortest, quickest, fastest, easiest way to solve this problem is to know or to remember that when you're dealing with the unit circle, the cosine of the angle is equal to your x-coordinate. Also, the sine of the angle is your y-coordinate, but you don't need that for this problem. So all you have to do is go to Desmos, do the cosine of each answer choice, and see which one gives you negative 1. And that's it. So for example, cosine 26 pi, positive 1, not the right answer. Cosine 27 pi, negative 1, there's our answer. Now, I'm still going to check the other two just to confirm that they are wrong, but that's it. So you don't need to spend any time. So correct answer is B here. You don't need to spend any time figuring out where exactly this angle falls, or the various which angles these are equivalent to, in terms of like the various axes, positive x, negative x, so on. But I will show the explanation for that method after this as well. All right, so first question we have here gives us the coordinates for 3 different points, and it wants to know about the measure of the angle formed by these 3 points. So if you go and sketch out, these 3 points here, you got F at 1, 0. G right at the origin, and then H is at negative 1y. So negative 1, it could be, up here technically, it could be down here, or it could also technically be right on the x-axis. So now we have to figure out which of these, multiple choice answers are the correct one. So here's the thing to know or to be aware of. All right. If you have learned about the unit circle, we know that we start here at 0. And then when you go 90 degrees in terms of radians, you would have pi over 2. And then over here you would have pi. And then down here you would have 3 pi over 2. And then when we go back to the beginning, we're back where we started. We're now gone around 2 pi radians, 360 degrees. So what you need to remember to solve a question like this is angles that terminate or end on the positive x-axis are basically going to be an even number in front of pi. 2 pi, 4 pi, 6 pi, 8 pi, etc. Whereas over here in the negative y-axis, you're going to have angles that are an odd number of pi. So for example, 1 pi like this, 3 pi, 5 pi, 7 pi, so on. And then the ones in between, so on the positive y-axis, it's going to basically be an even number plus 0.5 pi. So an even number plus 0.5 and then pi. So for example, think about it, you go all the way around once, you're at 2 pi. Then you go another half pi, you are at 2.5 pi. Or, it's technically, you normally would memorize it as 5 halves pi, but if you turn that into a decimal, it's just 2.5 pi. It's an even number plus 0.5. 2.5, 4.5, 6.5, 8.5, etc. And down here in the negative y-axis, it's going to be the same thing. It's going to be an odd number plus a 0.5 and then times pi. So, for example, this already has it. This is already 3 halves, which is 1.5. It's 1, the odd number, plus 0.5 pi. 3.5 pi, 5.5 pi, 7.5 pi, so on and so forth. Okay, so when you look at the answer choices, reduce them all down to that. So the first one is just basically 26 pi. That's an even number pi. That means it's going to be right here. Next, 27 pi. That's going to be here because it's an odd number in front of pi. 31 over 2, you divide that out, it's 15.5 pi, odd number plus pi. That means it's going to terminate down here on the negative y-axis. So 31 over 2 pi is down here. Last one, 29 over 2, that's 14.5 pi. And if you can't, if you don't know that, just do it in Desmos, do it on your calculator. So that's an even number plus 0.5. So that means 29 over 2 pi terminates up here on the positive y-axis. So if you notice, there's only one possibility to have one of these answers be correct. Okay, this the third point over here, basically the h point, it's impossible to terminate on the positive y-axis because it has an x-coordinate of -1, and it's the same thing. It's impossible to terminate on the negative y-axis because again, it has an x-coordinate of -1. So this one's out, this one's out. Get rid of them, and also it can't terminate on the positive x-axis because it would have to mean, again, it's got the thing over here of -1. So this one's out as well. So by process of elimination, it's going to be letter B. And specifically, the way this works out is that this y value is just 0. So in other words, point H is right here. The other 2 points, those scenarios do not work. And so this angle is basically going here to here. Now it's going around a lot more times. It's basically going around like, 13 times and then another half time to get 27 pi. But the point is, this angle is going to look right like this. Correct answer is going to be letter B. All right, let's move on to the next question. So here we have this equation, quadratic function, or equation, excuse me, and it's got some variables in it, r, s, and x, and they want to know what's the largest ratio of r over s for there to be at least one real solution. Anytime you see this stuff about, one real solution, no real solutions, that's usually a clue or hint that it's going to involve the discriminant. So if you go ahead and take that, b squared minus 4ac, we're going to go ahead and calculate it. So here the b is the 60s, and the a is the 6r, and the c is also 6r. And for there to be at least one real solution, that means we want it greater than or equal to 0. So, I mean, you could technically set it equal to 0. It doesn't really, matter. It's just in the end, technically it's greater than or equal to. Okay, so we get 3600 s squared, and then we multiply this out, we're going to get minus 144 r squared. I'm just going to set equal to 0 for the purposes of solving this. We want the ratio of r to s, so all we're going to do is basically get this equation so that we can get r over s at some point. So I'm going to divide by 144 on both sides, and I'm also going to divide by s squared. So that gives me on the left side a number, which conveniently works out to 25. On the right side, I have r squared over s squared. And now when I square root that, I get r over s is 5. So that means the largest possible ratio of these values is going to be 5. And that's what you would put down as your answer. So I can show you another way to solve this in Desmos. So if we go to Desmos and we're going to type in function, we're going to add some sliders. Okay. Now, I'm going to fix s at 1, so I'm not going to change that. And then I'm going to move r just to see, like, how, because I want r over s, so I want the largest r possible now. So I'm going to see how high can I move it such that there is still at least one real solution. So that means there is at least one x-intercept, okay? So keep sliding. Oh, so notice here it jumps up to 5, and there is exactly one x-intercept, i.e. one real solution, because it highlights the point here. If it was technically above, this point would not be on the axis, meaning it would not have a y-coordinate of 0. If it was below, there technically would be two other points highlighted. This would be the vertex, but there would also be two x-intercepts highlighted on either side. So this is the correct answer, and again, you can actually figure this out in Desmos, but there could be a problem that they structure such that the answer isn't a nice integer like 5. It's something with a decimal, and it takes a lot more work to figure it out. But for this specific problem, it's actually very easy to solve in Desmos. Let's look at another question here, number 4 at the top. So in this question, they basically tell you that you plug in some number for A subtracted by 7. So, or sorry, you take some number and you subtract 7 from it. You plug that into this function and you get 1 as your output. Okay? And then they want to know what is the value of A that this occurs for. So if you want to do this by hand, I mean, basically what you do is you just replace this with 1, and then you could go ahead and solve it and get x plus 13 equals 5x squared plus 9x minus 52. Now you have a quadratic. Okay, it just becomes 5x squared. Let's see here, plus 8x minus 65. Now this does not factor, so this you're going to have to solve either by quadratic formula or you're going to have to solve just by graphing it in Desmos. So I'm just going to go ahead and basically show you what the two answers are. You get 2.893 or negative 4.493. But remember, this is the whole value of what's being plugged in. In other words, these numbers are equal to A minus 7. So technically for A, you would add 7 to each of these. So when you do that, you get 9.893 or you get 2.07. So those are your two possible correct answers. Now, in terms of Desmos work, so again, we could just type in let's see here. We could type in the equation and it should give us the solutions. Yeah, see, it gives us two solutions right away. The problem is because of the format that it's in, it won't let me click on here directly, like to determine what the exact decimal value is. So all I'm going to do is graph a horizontal line. Yeah, see, it's still not, I thought it would let me click with the intersection, but it's still not letting me do that. So I guess, so alternate approach, what I would do instead is I would cross multiply and then graph the two sides, the left side and the right side. Get rid of this. See where okay, now I have the intersections and here I get the 2.893 that I had originally, that checks, and the negative 4.493, and then just add 7 to each of them and get it, and get your two answers. But again, you do have to realize that you got to plug a 1 in here, cross multiply it, then you could solve the equation just by graphing in Desmos, and then you have to remember to add 7 to both of each to get the actual value of A. So here you're given expressions for three angles in a triangle. And they tell you, A, B, and C, or sorry, A and B are constants. Which of these following statements must be true? So first thing I would do is I would just I would do picking numbers, and I would pick some values for A and B. Okay, so obviously if A is 1 and B is 1, then A is 90, this is 53, this is 37. So in this scenario, B and C are complementary angles, which means that the sine of B will be equal to the cosine of C and also vice versa. Sine of C would be equal to cosine of B. I mean, we don't have any expressions with that, but just in general. So right off the bat, you can get rid of this, you can get rid of this. So it's either this one or this one. All right, so let's pick some other values and just see, like how it works out. Well, so if A is 0.5, let's say B is 1.5. So that would make angle B 26.5. It would make angle C 30. No, that's not the right measure here. 7 times. Sorry, yes, it would make angle C, excuse me, I'm reading my notes wrong, 18.5. Plugging in A is 1/2 for each. And then it would make angle A 135. Now, just to do a quick check, to make sure like everything checks here, do these three angles add up to 180 degrees? Yes, they do. Okay, so these values work because they still make a valid triangle. All right, so now you just go to Desmos or on your handheld calculator, you calculate the sine of B and you calculate cosine of C. And what you're going to find out is they will not be equal to each other. So cosine 18.5, sine of 26.5. Let me just make sure that I am in degrees. I don't think no, it's in radians, but it doesn't matter. So right here you can see they're clearly not equal to each other. So therefore the answer is going to be D. Sine of B1 is 0.446 and cosine C1 is 0.948. So therefore, this is not necessarily true. It's going to be letter D here for the correct answer. Okay, next up, another question, fairly challenging question. This one, I think there was a diagram, and you basically had a rectangle, and on top of the rectangle was a semicircle. Ignore the poor drawing. Um, the width of the rectangle here is 12. The diameter of the semicircle is 48. So that means from here to here was 48. Also means the radius of the semicircle is 24. And this is also half the length of the rectangle. So that meant this other part here is 48. Therefore, total length of the rectangle 96. And they tell you, the area of both figures is A plus B. What's the value of A plus B? So really all you're doing here is you're going through figuring out the area of the rectangle, which is just 12 times 96. That is going to come out to be 1182. And then the area of the semicircle, which is basically just, it's pi r squared, but then you have to divide it by 2 because it's half a circle. So that's just going to be pi times 24 squared, and then dividing that in 2. So that is 576 pi cut in half. That comes out to 258 pi. So this is your A value, this is your B value, and then you go ahead and add them. 258 plus 1182. That should come out to a total of 1440. That's going to be your correct answer. Note that some people also reported this problem had a minus sign here between them. So if that was the case, you would technically do 258 minus 1182, and whatever number that worked out to, maybe negative 900 something, negative 924, I think. That would be your correct answer if it had minus there instead of plus. All right, number 20 here. This is a predator-prey question. This seemed to be a very common question on the June 2024 test. Easiest way that I find to solve this is to start with the same value for each, okay, which is 100. I mean, obviously you have to start with the same number because it tells us that there are the same number. But what I meant is the easiest way is to use 100 as your starting value. So the number of prey increased by 1,700%. Okay, so 1,700% is equivalent to 17 as a decimal. So you take 100 and you multiply by 17. That's 1,700. But that's the increase. In other words, you have to add that to the original 100 to get the total number of prey after the increase as 1,800. Following the same pattern for predator, 350% is 3.5 as a decimal. Multiplying it out, you get 350. Again, that's the increase added to the 100 you started with for 450 predators. Now, the number of predators is what percent less than number of prey. So all we have to do is find the difference between them. 1800 minus 450, which is, so it's 1350. Number of predators is 1350 less than number of prey. And then to convert that to a percentage, we divide that by the number of prey because that's what's listed second, in this expression. So 1350 divided by 1800, that just comes out to 0.75. So as a percentage, of course, it's just 75%. So correct answer for this one is just 75%. And again, I think it's so much easier to do this just picking numbers using actual numbers. I'm not going to bother going through and like calculating this out with variables, like choosing whatever x to be the initial amount of each and then like adding 17x and adding 35 or 3.5x and whatever and going from there. Just so much easier I think to do it this way with actual numbers. We have a fairly complicated question where you're given like a quadratic. Um, Basically, it's a quadratic, and you've got some parentheses or whatever that need to be multiplied out, and you also have like essentially an equivalent expression that you're trying to make it equal to. But like, notice they have these like a, b, and c over 6 things, whatever. I will show you how to do this in Desmos, and it can actually be done in minimal time. Actually, I'll show that first, and then I'll show the by hand method. So what we can do is we can get the values for A, B, and C by doing a regression and setting the two sides equal to each other. So we tilde this. Should be 5x minus 3. Yep, it is. 1. This has to be a 1. Okay. So it's not correct just yet. What we have to do is define x1 as a list. That way it'll treat the x1 as a variable and not as a constant. There we go. I also have to enter in at least 3 numbers for it to do it correctly. I believe the reason for that is the fact that there are 3 constants, a, b, and c. If I add a fourth one, does it change it? Doesn't look like it. No, you can add a fourth, you can add a fifth. Yeah, it doesn't change it. But you need at least 3. If you don't have at least 3, notice it's all messed up. It doesn't work properly. All right. So now it gives me a, b, and c. Scroll down. What is it? 72. Okay. That is the correct answer to this, by the way. It is correct answer is 72. So that's how you can do this problem entirely in Desmos. Again, I'm using a regression. I'm left side tilde right side. Every x becomes x1, and then I define x1 as a list. I put at least 3 elements in it. A plus b finds a plus b plus c. Okay, now here's how you could actually do this out by hand. It's actually not that bad. I'm going to skip some steps again, just it does take a little while. So first thing, this is going, if you square this out, it's going to be 25x squared minus 40x plus 16. For the other one below it, it's going to be 25x squared minus 30x plus 9. Let's check my notes. Okay. Then if you multiply everything out, I'm just going to do these vertically so they all match up. You've got negative 300x squared. Down here, you've got 150x squared. Negative 150x squared is the overall result. Okay, then you got 480x. Then we've got minus 180x plus 300x. Let me fix that. That is, yes, okay. And then 12 times 16. What do we have here? Negative 192 plus 54. That becomes negative 138. Okay, So if you do this all out, blah, blah, okay, you have this. But now the problem is here it's got this like a over 6, b over 6, c over 6. So technically that means, a over 6 is equal to negative 150. So you just got to multiply that by 6 and get a to be negative 900. Same thing with b. B is going to be 300 times 6, which is going to be positive 1800. Same thing with c. C is going to be negative 138 times 6. That is going to be negative 828. You add these all together, you get 72. And notice these numbers match the same values I had right here when I did it in Desmos. Negative 900, 1800, negative 828. Okay, add them together, you get 72. So this is how you could do it by hand as well. All right, here is an alternate way that you could solve question number 7 from my August 2024 Digital SAT Math Part 1 problem set. So this was suggested by YouTube user Mangler241, who said that you could just plug in 1 for x and then get the values for a plus b plus c from that. And it appears that yes, this is correct and should work. So, for example, notice if you plug in 1 for x on the left side, 1 squared is just 1. 1 times 1 just times anything, it's just that anything. So you get a over 6 plus b over 6 plus c over 6 equal to, now we're going to get some number on the right side, and then we just have to multiply that number by 6, and we'll have a plus b plus c. And plugging in 1 here, I mean, you could do it by hand. I guess I'll probably just do it by hand. I mean, you could go to Desmos, but the actual work is not that difficult because, again, we're just plugging in 1. So 5 times 1 is 5. 5 minus 4 is 1. 1 squared is 1. Same thing here. 5 times 1 is 5. 5 minus 3 is 2. 2 squared, this whole thing becomes 4. So we get negative 12 plus 24. So a plus b plus c, I'm just going to go ahead and multiply, by the 6 is equal to 6 times, and then negative 12 plus 24 is 12. 6 times 12, which is just 72. Same answer that I got either doing it in Desmos or doing it all out by hand, but this is obviously much quicker, much easier, and much faster. So again, this is an alternate solution you could use by just plugging in 1 for the value of x, and on the left side, you get just, a over 6 plus b over 6 plus c over 6, which allows you to easily solve for a plus b plus c. On the right side, you get a numerical value, and you just have to multiply that by 6 to get what your answer is. So thank you to this YouTube commenter on my page who suggested this method, and here's the video just to confirm that yes, you can do this. Next up, question number 4. We have one which looks very tricky. It actually took me a little while thinking about this to figure out the correct way to solve it. Initially, I was thinking about taking this 36 and putting it into the radical, so it would become the square root of just a whole number with nothing in front, and then like trying to relate the two somehow that way. But the easiest way, and it's actually not going to be that much work to figure this out, is to go ahead and square both sides. That will cancel out the large radical on the left. On the right, you technically have to FOIL this. So that means, it's going to be r plus root p times r plus root p. When you FOIL this out, you will get r squared, and then the inner and outer terms are going to be the same. They're both going to be r square root p, and then root p times root p is just going to be p. So now you can match up essentially or equate it's like the terms that look the same or that have the same format. So what that means is 36 root 6 has to equal this right here. So in other words, 36 has to equal 2r. Therefore, r has to be 18. Also, 6, the number to the radical, has to equal p. Therefore, p has to equal 6. So what is r plus p? Well, it's just 18 plus 6, and it is 24. And that is the final answer to this problem. Now, just to confirm that this is correct as well, if you take r squared, which is 18 squared, and you add to that p, which is 6, notice you get 330. So these two terms here do equal 330, which matches, this number that's out in the front. So that just confirms we have the right number. So correct answer for this is just 24. This one, what you can technically do again, this is not something I'd really ever seen before or thought of, is you can take the expression on the left. So this one's going to be done entirely in Desmos. Okay, we're going to type that in. And then we set this equal, and then I'm going to replace the letters on the right side with X and Y. Okay, so it's basically graphed out a function here. And it wants to know what's the value of r plus b. But the problem is, notice there's like tons of points here. But the thing is, there are only a handful of points where uh, r and p are basically integer values. That's really essentially what we're looking for. That's what you get when you solve it out. You get, 18 and 6. So what you add is this little command here. So this mod command basically takes the remainder and it wants to set the remainder um, with x, dividing it by 1 such that it's less than 0.001. So in other words, it's telling it to return only integer values. So you look at the points here. Let's just like zoom in. Now you can see it's only like finite points, right? It's not a curve. So like here is an integer, essentially an integer value of x. Um, But what we need to do is look for both where x and y are both going to be integers. So in other words, we're looking for points that are exactly on the grid or intersection marks on the graph. So this is the correct answer, 18 comma 6. This one, okay, notice here technically it's undefined. That doesn't, so that's not going to be something. This one, again, it's okay, it's not exactly 16 or whatever. So therefore that one's not an integer value. This one, again, you know, there, not exactly an integer value. It's close, but not quite. So this was just an alternate approach. Don't know. I mean, guess this is something you could use if you're really struggling with a problem that's identical to this or come across this. But it is just another method that works as well. We have here a circle and we have an equilateral triangle which is inscribed inside of it. So let me see if I can get a rough picture up here. Here is our circle. Let's see here. Okay, this obviously is not equilateral, but whatever. Let's just pretend that it is for these purposes. So we know that the total perimeter is 780. Okay, so we can divide that by 3, and that's going to give us 260. So that means each side of this triangle is 260. We also know they tell us the circle has a radius of a root 3. So basically here in the center of the circle, okay, there's multiple ways you could draw or divide this up, but here's a radius and here's a radius. Ignore the poor drawings, of course. This is a root 3, this is a root 3. So what ends up happening, and I'm just going to draw a separate picture to kind of illustrate this, is basically like this is 60, this whole angle 60, this whole angle 60, but what it ends up splitting this triangle into is basically this is 120, this is 30, this is 30. Okay, this is a root 3, this is a root 3. This is just a kind of like a magnified portion of this triangle right here. Then we drop this down. It makes two congruent triangles. Again, ignore the poor drawing. This is 60, this is 60. So now what we have to do is basically this whole thing down here is 260. So it gets split up into 130 and 130. All right. So now what I'm going to do is this is 130 is the long leg in the 30, 60, 90 triangle. So I'm just going to call this x for the short leg. And I know that x is equal to the long leg, which is 130, divided by root 3. So if I go ahead and do that, and then technically simplify it by rationalizing the denominator, I get 130 root 3 over 3. So that is the vertical, that's this vertical side right here. It's the short leg in our 30, 60, 90 triangle. Now to get the radius, I just have to take this and multiply it by 2. Radius is also the hypotenuse of this triangle. So 130 root 3 over 3 times 2. 260 root 3 over 3. So that's what the hypotenuse of this triangle is equal to, and this is equal to a root 3. Okay, so that means that a technically is equal to this right here. So you can input 260 over 3. You could also input 86.66 if you wrote the decimal form and you truncated it, or you could put 86.67. Okay, so the a value for this circle, which is part of the radius measurement, is either one of these, three acceptable values: fraction, truncated decimal, rounded decimal. Next up, we have question number 7. Here we have one that dealt with basically proportions and area. So we have a square map. Each side of this map, 55 inches. All right. 1 inch on this map represents 13 miles. Now, there's a smaller version of the map, and the side lengths are 70% smaller. So if we just start with 55, we take 0.7 times 55, we subtract that from 55, we get 16.5 inches. So the smaller map is 16.5 times 16.5. So now basically what we're saying is this small map, which has a side length of 16.5 inches, okay, that has to represent a total distance of um, 55 times 13. Because in the large map, like 1 inch is 13 miles. So that means in the large map, basically you have 55 inches times 13 miles per 1 inch, and that just comes out to 715. So the small map is representing the same total distance, the same 715 miles, but we only have 16.5 inches to do it. So, what is the actual distance represented by 1 inch on the small map? Well, we just divide this by 16.5. So if you do that, it should come out to 43.3 repeating. Let me just double check these calculations in Desmos. So we've got, first of all, 55 times 13. Okay, 715 total miles. And then we're just going to divide that by the 16.5 inches, which is the side length on the small map. Yep, 43.333 repeating. So you could put the answer in as 43.33. Let me see if there's a simplified fraction. Easy simplified fraction? Yeah, or you could also do 130 over 3. Okay, so 43.33 or 130 divided by 3, either of those would be acceptable. The last question here, we have a word problem that deals with 3D shapes. So basically, we have a rectangular prism here. It looks something kind of like that. The height of this is going to be 24 inches. The width is going to be 4 feet here, and the length is going to be 20 feet. And we're given a total cost to fill this, and they want to know the overall cost in terms of dollars per cubic yard. Okay, so there's a couple things going on here. First, we need to find the total volume of this prism, but we need everything to be in the same unit. So what I did first is I converted the 24 inches to just 2 feet. Okay, and then I said, okay, the volume is going to be length times width times height. So we got 20 times 4 times 2. So the total volume, and again, this is in cubic feet, should work out to 160. Now what you have to do is you have to convert that to cubic yards. So 160 feet cubed, and then times 1 foot is 3 yards. And you have to do that 3 times because it is a volume, because it's 3 dimensions. Now, if you didn't want to write out 3 times, you could technically just take this and you could cube it, and it would be like 27 on top over 1. So if you wanted to do it that way, I mean, that's fine. Basically, the whole thing is you're going to end up multiplying. Um, oh, sorry. These are all backwards. It should be 3 yards. 3 feet is 1 yard. Gets smaller, not bigger, for number of yards. 3 down here, 1 up here. Okay, so now if you go ahead and just do this out, multiply it all through, it should come out to 5.9259 cubic yards, the total amount of soil needed for this. Just go to Desmos to test, confirm that this is correct. So we got 160, and then it's times 1/3, times 1/3, and times 1/3 again. Yep, 5.9259929, but yeah, whatever. It's really just 160. You could also keep it as 160 over 27 if whatever you want to do it that way. That's fine. All right. So now this is the total volume in cubic yards. They want to know the cost in dollars per cubic yard. So now dollars on top, cubic yards on the bottom. So we put the $231 on top. We put the 5.9259 blah, blah, or if you want to use 160 over 27. Either way, you put this, just type this into your calculator, type this into Desmos. The answer that we're going to get is going to be 3898, rounded to the nearest cent. Now, a couple things. So first of all, again, if you wanted to divide 231 by that value, I would not just type it out by hand. What you want to do is you want to define this as an exact value, which is called V. And then down here, I'll type V and it'll carry over. And so notice here it's $38, and then the rounded to the nearest cent would make it 98 cents. If you type it out as just 5 point, even if you go 9259, 2592593, you could end up getting it slightly wrong. The rounding may not work out to be the same, but when I define it as V, it's using the exact value. It's not rounding it at all. And of course, you could also put 160 over 27 and, do it that way and get the same answer. But correct answer for this one is just going to be 3898. All right, so starting off with this first one, this is a fairly tricky one that I've seen a number of people post about. So basically, this function is positive between a and b. Okay, so a is a 0 or an x-intercept. B is also a 0 or an x-intercept. Same thing with c. Okay, so a, b, and c are all x-intercepts or zeros, roots, whatever you want to think about them. All right, and then we also have some point on this graph, r comma s, whatever, and they're saying if s is equal to 6, so this point is really r comma 6, i.e. a positive y value. The fact that it's 6 is irrelevant. It's just the fact that it's positive is what's relevant. Okay, which of the following could be true? So there's multiple ways that you could kind of think about this and figure it out. There is kind of like, there's a theoretical way, there's a way using the graph. I'm going to do it by using, first of all, by picking numerical values for A, B, and C, because I think it's easier to work with that instead of a bunch of letters, floating around, A, B, C, R, S, blah, blah, blah. So I'm going to choose just A equals 1, B equals 4, okay, C equals 5. So now what I can do is, first of all, I'm going to get the graph of it. So that's good. And getting the graph is going to help me visualize, what exactly is going on here. All right, so here is the graph, okay, of our function. Basically, here's our, A value. You can think of it, here's our B value, here is our C value. All right. Now, first thing to check is when x is between a and b, in this case between 1 and +1 and +4, is the function positive? Okay, yes it is. You can see it's, it goes up here and comes down, but the y values are all positive. All right, so that condition is met. Now, if s equals 6, which of the following could be true? So in other words, if you have a point value here, which has a positive value of 6, so notice there are technically multiple places where this could be true, okay? There's this right here, there's this one right here, and there's also this one right here. Notice the first two are between A and B for the x value or the r value. Notice the third one is to the right of C or greater than C, okay? Let me just get rid of these because it's confusing. Right here, this point right here, 5.4 and 6. The 5.4 is to the right of or greater than the C, which is right here at 5, 0. So when you go through these answer choices, R is greater than C, yes, definitely possible. What about between B and C? Well, if we go back to the graph, is it possible to have a positive value between the B value and the C value? Okay, and the answer is no, it is not. And the reason is because the shape of this graph and the fact that it's a cubic polynomial and the end behavior and the fact that the leading coefficient is positive, which means it has to be going down on the left and up on the right. So therefore, because of that shape, because it's positive between like A and B here, it has to then be negative between B and C. So this one will not work, and it's going to be the same thing with the first answer choice as well. If I go back to the graph here, basically to the left of A, it has to be going down, okay? Because A is positive at 1 and it has a multiplicity of 1, that means the graph is going to cross there. It's not going to bounce or it's not going to touch. So if it's positive when x is greater than a, i.e. to the right of a, then it has to be negative to the left of a when it's less than a. So that would eliminate this one as well. So that's how you could get this just by kind of like picking some numbers and looking at the graph. But here's an alternate way to kind of think about this or visualize this using signs. So, and again, I'm going to just pick numbers here. And actually for this example, I'm going to make b equal to 3 instead of 4. And I'll show you why in a second. So all the conditions are still met here. If you go to the graph and I just change this to 3, okay, notice like same exact conditions are met. It's still positive between A and B right here and, so on. Okay. So now what I would do is I would look at the signs. Okay. So I'm going to pick some values just to plug in for x that fall in each of these intervals, and then go ahead and see what the signs are. So for example, r is less than a. So again, here a is 1, b is 3, and we said c is 5. So let's say you plug in 0, for example, for a, or excuse me, for r here. So first, r is less than 0. This is the r is less than a interval. Okay, notice 0 minus 1 is going to be negative. I'm not concerned with the value. I'm only concerned with is it positive or negative. Then we do it for this one. 0 minus 3, that's going to be negative. Here, 0 minus 5, that's going to be negative. The 2 out front is positive, so the end result, negative times negative times negative, the overall end result is a negative value. Therefore, could the y value be positive 6? No. Do the same thing for r is between b and c. The reason I shifted this to 3 is now just so that I can use a whole number. I can use 4 instead of, if I had 4 and 5, I would have to use like 4 point something to go between them. So again, the 2 out front is positive. 4 minus 1, that is positive. 4 minus 3, that is positive. But over here, 4 minus 5, that's negative. So positive, 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 but we have one negative. Therefore, the overall end result would be negative. We can eliminate this one. It's not going to be correct. Now we'll pick one for where r is greater than c. So let's say r is equal to 6. So we've got the positive out front still. 6 minus 1 is positive. 6 minus 3 is positive. 6 minus 5 is now positive. It's all positives all the way across. Therefore, you could have a y coordinate of 6 because it's when it's greater than c, it's going to be a positive value. So that would allow you to, again, eliminate these two. It's going to be this one only. Correct answer for this is going to be letter C. You have 12 people that went to a webinar. So the first webinar, or sorry, 1,250 people. And then of those, 64% went to a second webinar. So 64% went to a second webinar. Okay, and then 32% of the people who went to the first and second went to a third. So whatever this number is, which then 32% went to a third. Of those who went to the first but not the second, which would be basically 36% over here, because you either went to the second or you didn't, so these two percentages have to add up to 100, so that's where the 36 comes from. 34%, so this is some number, also went to the third. Okay, so from here to here, basically 34% of that value went to the third. How many people went to both the first and third webinars but not the second? Okay, so on this one, all we have to do is calculate, first of all, 36% of the 1250. So that's going to be 450 people. And you could actually, just so you know, with percentages too, you could actually type it in like this if you want to. But anyways, it's 450 people went to the first but did not go to second. So this is number of people that went to the first but no second webinar. Now, of that group of people, 34% also went to the third. So you're just taking 34% of the 450. And it's going to be 153. So down here, it's going to be 153 people that went to the first webinar and the third webinar while not attending the second webinar. And notice that this like 64% thing, technically we need to know what the percentage is in order to know how many percent that did not attend the second, but we don't actually have to calculate the value for the number that went to the second. Or this 32% here that went to the first and the second went to the third, that again, that's completely irrelevant. We don't need that in any way at all. All right, last question on this digital SAT August 2024 math problem set part 3. This one is very, very similar to a problem that was in part 1. The work and pretty much is the same until the very end. In the part 1, I think it was asking for the height. This one's asking for the volume, so it's just like one extra step. But the overall process is almost identical. So you have the pyramid with the square base. Okay, and the total surface area is 3920. The lateral surface area is 2320. The lateral surface area is the area of the 4 like triangular faces up here, but not the base. So you just subtract these two numbers to get the base area. Usually it's B in the formula. And if you do that, you just get 1600. So that means the area of this square base is 1600. Therefore, if you square root that, the value of each side will be 40. Okay, so the square, that's the base, is 40 by 40. Base area is also 1600. So we'll come back to that because we'll need the volume formula, which is 1/3 times the base times the height in a little bit. All right, so next we have to find the height. The way we have to do that is basically, so the height is here. You have to set up a triangle, and you make a right triangle where you have the height, and then the hypotenuse is the slant height, which I usually call L. And then this side down here is basically half of one of the sides of the base, meaning it's 20, not 40, because it only goes half the way across. So in order to find the height, we need to know L, the slant height. The way we get that is we look at one of the triangular faces, and we know that the base will be 40, all the way across down here, and then this height which is the slant height, is L. We're going to figure that out using the fact that the total lateral surface area is 2320, and we divide that by 4 because there are 4 triangular faces to get 580 as 580 square meters as the area of one triangular face. So in other words, 580 is equal to 1/2 times the base times the height, which is the slant height here. So if you go ahead and solve this out, this is just basically 20, divide by 20, divide by 20. The slant height is equal to 29. So now I can go back here, I can replace this with 29. Now you can use Pythagorean theorem to find the height. H squared plus 20 squared equals 29 squared. It's going to be h squared is 841 minus 400, or in other words, 441 for h squared. Square root that. H is going to be 21. Okay, so the height of this pyramid is 21 meters. Now we go back to the volume formula and we just plug in the area of the base, 1600. The height, just found it to be 21. So you could cancel this out, you could just type this onto Desmos. Basically, it's going to be 11,200. That's what cubic meters, that's what you get for the volume. So 11,200 is the correct answer. Okay, the next question, you have a thing about a tree growing at a certain rate, but it's in but it's in terms of months, but they want to know the growth in terms of years, and they have a bunch of variables here. We have M and K and everything. So there's 2 ways you could do this one. First, I'll show you kind of the theoretical solution behind this, and then I will show you how you could solve it using picking numbers. So I'm going to start off 33 centimeters every M months. Okay, so I just set up a ratio like this. Now, let's say we want to find the growth of the tree. So notice here in my original thing, growth is on top, right? 33 centimeters is growth, and this is basically time. So now if I want to find the growth, I'm just going to call that X, because you want to know the growth of the tree after K years. So down here is where you would put K years. But here is the thing that's tricky. Here's the thing that's confusing. In order to set these equal, you have to have the same units on both the top and the bottom. So the problem is right now on the left side and the bottom I have months, but on the right side I have years. So technically you have to take K years and you have to basically convert that or represent that in terms of months. So the way you do that is it just turns into 12 times K months. So if you think about that, okay, basically it's like, just think about this little separate, unit conversion here. You have K years, right? We know that 1 year has 12 months. So now if you went through and multiplied this through, you would say, okay, K years is equivalent to or is the same as just 12 times K months. And you just think about it in your head, right? 5 years, if you wanted to find how many months that was, well, you just take 5 times 12 and you would get 60, right? Just multiplying the number of years, which is K, times 12. So now what I can do in the bottom here is I can just replace this with 12K, which is the number of months. Now I have the same units everywhere. So technically what I'm solving for is this right here. What is the growth that corresponds to K years? Or again, I changed it or converted that to 12K months. So now all you have to do is basically, you can either cross multiply or it's actually going to be quicker and easier just to multiply both sides by 12K because then you don't have to divide again. So in other words, 12K is going to cancel out. And then now on the left side here, we have 33 times 12. That becomes 396. We also have a K. And on the bottom, you have an M. Now we don't have any units in the answers, so whatever, just ignore that for right now. So ignore the centimeters, ignore the months. But this is the correct answer right here. It's letter C. Now, here is how you could do this by using the strategy of picking numbers. So what I said is, okay, I said 33 centimeters over 3 months. Okay, that means it's basically the equivalent of 11 centimeters per 1 month. And then I said, okay, let's let K equal 1 year. So in 1 year, we would expect the tree to grow how much? Well, if it's 11 centimeters in per month and 1 year is equal to 12 months, well, just multiply that. 11 times 12, 132 centimeters is the total growth we would expect over 1 year. Okay, again, where I set m equal to 3 and I chose k equal to 1. Here's my m, here's my k. Now what I'm going to do is just go to the answer choices and plug in m and k, and I'm looking for the answer choice that will give me 132 as my answer. And it's going to be so much easier to do this by just defining m and k as 3 and 1 and then just typing in each thing. So this is answer choice A. That is obviously not correct. For answer choice B, notice here I can just switch m and k. Not correct, not 132. Next, answer choice C. Now I got to put k back up here, m down here. 132, this appears to be correct, and then you could just check answer choice D. 1188, not correct. Okay, so this is again how you could use picking numbers as an alternate solution method to solve this problem. Let's go ahead and get started on this first question here. We have a right triangle. It's inscribed in a circle. So let me just get a nice picture up over here. Okay, so here is our circle. Now, you have a right triangle inscribed in it. So I'm just going to say it looks something like this. Here's my diameter going through the center of the circle. All right, so I have my right triangle looking something like this. B is the right angle, so I'll label this B. Okay, AC is the diameter, so we'll label this. And now basically BD is an altitude to the hypotenuse, okay? So you have a perpendicular line coming down right here, intersecting the diameter or the hypotenuse at point D. All right, they tell us that AC is 113, so this whole thing right here, 113, and they tell us BD is square root of 222. Now, I saw multiple versions of this question posted online, with different numbers, but the process is going to be the same for each one. So, excuse me, there are multiple, there are like technically two different approaches you could take to this. You end up getting the same answer, obviously. So one approach is to say, okay, I'm going to label this x, and therefore this segment, CD, is going to be 113 minus x, all right? Because the whole thing is 113. So if I just say some part of it is x, the other part has to be just, 113 minus that x part. Now you can set up a proportion because BD right here is the geometric mean between the two parts of the hypotenuse it splits up. So what that means is you can say root 222 over x is equal to 113 minus x over root 222. Really, what you're doing here is you're just basically matching up parts of the triangles. So it's like, you're basically saying, in this small triangle on the left, like long leg over short leg, and then that's going to be the same as the triangle on the right, long leg over short leg. Okay? Because when you draw the altitude to the hypotenuse of a right triangle, you make three similar triangles. You have the large overall triangle and you have the two smaller ones. They're all similar to each other. Anyways, you go ahead and solve this out. You cross multiply root 222, root 22, just 222. Cross multiply this, you're going to get 113x minus x squared. Then you can bring this over, x squared minus 113x plus 222 is equal to 0. This, you could go to Desmos and solve, or you could just factor it. I'm just going to save time and factor it because I already know what the answer is. Okay, it's going to be x minus 111 and x minus 2. Okay, so when you solve this out, the two answers you get are 2 and 111. Notice if you plug them in, I mean, it works out, the same thing, same way regardless. So looking at the picture, at least the way that I have drawn it, um, I have CD as the larger side and AD as the smaller side. So therefore, the 111 would, correspond to this here. Like I would use the x equals 2 solution, which means this is 2 and this is 111. So we'd have 111 over 2. And of course, that just reduces to 55.5. So the correct answer to this is going to be 55.5. Now, an alternate approach that you could take, I mean, it really is technically the same approach, so to speak, but what you could do is, let me just make sure I have this correct here. You can set up two equations, basically with x and y, and then you can graph those two equations out, and you're going to just look for the intersection points, which are going to be the same as the same values that we found solving this quadratic equation. So basically, all you would do, and again, it's not going to be that much different. Like if you wanted to say this is x, and you say this part is y right here, then the two equations you're going to set up are going to be x plus y equals 113, because together they form the diameter. And then the second one is just the geometric mean, um, essentially equation simplified. So it's like really if you had this whole thing here, but you just made this just a y. And second equation, so the second equation is going to be xy equals 222. Okay, so this is just kind of an alternate way to solve it because then you could just go to Desmos. Okay, and again, you could just type the two equations in. Got to zoom out a little bit here. Okay, where do they intersect? Well, 2, 111 or 111, 2. So it gives us the same answers. X is 2 or X is 111. Okay? Or X is 2 and Y is 111 or Y, vice versa. X is 111, Y is 2. So then you could just plug in the same values for CD and AD and, get the same exact answer. All right. So slightly different approach, but really you're really getting the same answer. You still have to use the geometric mean property of matching up the corresponding sides from the similar triangles. All right, next question. Here you have an equation, and you're told that the sum of the roots for this equation is equal to 3k plus 29, and you're told to find the value of a. So this is a tricky problem. So far, I've only come up with one way to do it, but there might be other possible ways as well. So the way that I figured out how to do it is to first move everything over to, say, the left side of the equation, and then I'm going to factor it by pulling out a common factor. So I pull out a factor of x minus k. That leaves me with x minus k, and then minus k minus 5a. Okay, so now I can simplify inside this giant bracket all the terms that are remaining into negative k minus k is minus 2k, and then minus negative 5a is plus 5a. So now I have two factors, and I can set each factor equal to 0 and solve for x. So notice the first one is just going to give me x equals k, so that's my first root or my first solution. The second one is going to basically give me 2k minus 5a. I just set this equal to 0, I subtract 5a, and I add 2k to move them over to the right. So the sum of the roots is equal to 3k plus 29. So that means k plus 2k minus 5a equals 3k plus 29. Notice what happens here. All the k's cancel out. This is equal to 3k. Well, subtract 3k on both sides. They're going to cancel. That's what's supposed to happen. Otherwise, you're not going to be able to solve for a numerical value for a. So I get negative 5a equals 29, divide by negative 5, a equals negative 29 fifths. Okay, so now I can go to Desmos just to check that my answer is correct. I don't know of a way to explicitly solve this problem in Desmos fully, but if I just go in here and I add some sliders, okay, so I'm going to set a equal to the negative 29 fifths value that I found. Okay, so if I just set k equal to 1, and now 3k plus 29, okay, is equal to 32. So are my two roots, which are the two, like, which are the two vertical lines here, do these two roots, x-intercepts, add up to 32? Yes, 1 plus 31 is 32. Okay, what about if I go out here? Do they add up? 4.4 and 37.8. Well, now notice, sorry, since I moved my k value, sorry, my 3k plus 29 values change. So 4.4 plus 37.8. Do they add up to 3k plus 29, 42.2? Yes, it checks. So this is just confirmation that we do have the right value for a. Here's how you could solve this problem using Desmos. And there are two methods, and I'm going to demonstrate both of them. So for the first method, what I'm going to do is basically just take this function and get it equal to 0, this equation, excuse me, and get it equal to 0. So I'm going to subtract this whole term over to the other side. So you end up with something that just looks like this. All right, and then I'm going to do regression. And specifically, I'm going to do regression to the basically the factored form, intercept form, or factored form of this quadratic. Okay, so there's the there's the whole, basically now it's the left side of the equation. So first I'm just going to put a constant out here for vertex form. Usually I would use a, but because this already has an a in it, I can't reuse that. So instead I'm just going to use m. And now because this is a quadratic, there are two different, there's going to be two roots. I'm going to use b and c to designate the roots, and that's going to be it. So now, and by the way, I should misspoke. I'm doing intercept or factored form. I'm not doing vertex form, but we still need this constant out here, m, just to get everything worked out properly. All right, now I know that the two roots, so b plus c, those are my two roots, equals 3k plus 29, but notice nothing's happening. That's because this equation needs to be solved for one letter. So now I'm going to set b equal to 3k plus 29 minus c. And then last I had my element list. Once I do this, notice it gives me the value for a, negative 5.8, or as a fraction, negative 29 over 5. That's my answer, done entirely in Desmos. You do not need to do any algebra, except for basically rearranging the equation here, and essentially getting it equal to 0. All right, now here is a second method that you could do in Desmos. So let me clear out a bunch of this stuff. So I'm going to start in the same basic manner, which is to turn the equation equal to 0. Move the terms on the right over to the left, but then I'm going to actually write it as a function, so f of x equals. Then I'm going to do a regression statement, and basically my first root is x1, my second root or solution is x2, and then the other thing is I know that the sum of the two roots, meaning x1 plus x2, and you could use different letters here. If you wanted to use b and c like I did on the last one, that's fine as well, if it's easier to think of it that way. So now, what are these all equal to? Well, f of x1 is equal to 0 because it's a root. F of x2 is equal to 0 because it's also a root. The sum is equal to 3k plus 29. Now, it's not giving me the right a value, and the reason is because the regression is finding the same roots or the same values for x1 and x2, so we just have to add a constraint in order to fix that. Once I specify that the second root is larger than the first one, now it finds the correct value of a, negative 5.8. For some reason here, it won't let you give the fraction option to click on it, but this is a second method. This is what I call the list method or list approach. The first approach I call the factoring approach to solve this sum of roots problem. If you want more information on how these methods work, more practice problems related to them, please check out my Ultimate Desmos Guide to Digital SAT Math because both of these methods are demonstrated in it with example practice problems. All right, next up, problem number 5. Here we have 2 lines. And you're told the system has no solution, and you're basically asked what number cannot be the value of a. So in other words, a can be basically any number except for what. So I will tell you the correct answer to this is going to be 0. And the reason is because for this system to have no solution, you have to have 2 parallel lines. But if a is 0, these 2 lines will not be parallel because if you take the second equation and you go ahead and you just rearrange it, so let's say you move the by term over here, you move 36x, negative 36x over to the right. Okay, so to put it in slope-intercept form. We get something like this, divide by 1 minus b, 1 minus b, okay, 1 minus b. All right, so now let me just get rid of this. So now I have it in slope-intercept form. So notice the slope of this line is 36 over 1 minus b. Notice this could be equal to any number except 0. It's impossible, no matter what value you plug in for b, it's impossible for this to equal 0 because you have a 36 on top. The only way you could equal 0 is if you had a 0 on top, which we don't have. So 36 over any number is never going to equal 0. So that's why it cannot be 0. But you could also see this if you go to Desmos and we just graph out some of these equations. So let me do the first one. Okay, so whatever, we can add a slider for B. Okay, and then whatever, we can just add a slider for this. Okay, so this one right now, the slope is like real steep. Let me just increase the value so it's not. Okay, so for the first line, the one that has the negative 36x plus y, on the left side of it, right? You can increase this as much as you want, up to like whatever 2000, and it's going to get flat, but the slope is never going to actually equal 0. Okay, whereas like if you set this equal to 0, these are not parallel. I mean, you have to like zoom out a ways, but you can see eventually they'll cross. See it's way out here at negative 277.722. So the correct answer to this is 0. And again, the whole reason is because in the second line, if you go ahead and put this into slope-intercept form, the slope can be any number, positive or negative, depending on what you choose for b, except that it will never equal 0 because there is nothing you can plug in for b that will make the top where the 36 is equal to 0. Okay, question number 1. Here we have a right triangle, and first thing I'm going to do is just sketch out this right triangle, and I'm going to label the right angle down here x because it's given in the problem. Let's call this angle up here y and this angle z. Now we have line WX, which is perpendicular to YZ. Basically what we have here is a situation where we have a right triangle and we're just drawing an altitude to the hypotenuse. So there's our altitude. And you're also told, okay, WX is 531 and WY is 708. Find the value of tan Z. So there are actually at least 2, if not more, different ways to solve this problem. So, excuse me, one way is I went ahead and I said, okay, looking at this small triangle at the top here, XYW, okay, the tangent of angle Y is equal to its opposite side over its adjacent side. Therefore, Y is just equal to the arctan or inverse tan of that ratio. So if I go to Desmos and do that, that'll give me the measure of angle Y. And then Z is just going to be 90 degrees minus that. And then after that, I can just take the tan of angle Z. and get my answer. So let me just slide this down here. Okay. So first thing I want to do is inverse tan of 531 divided by 708. Now I need to make sure I'm in degrees and not radians. Click the little wrench icon and then choose degrees. Okay, so there we go. It's 36.4. What I'm going to do next is I'm going to define this as y. That way I can carry through this value without having to worry about typing everything out and getting the exact value of it. So now, so if you want to write this down here, whatever, 36.86, dot, 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 dot. Okay, so now we know that y and z together add up to 90 degrees because, well, x is 90, so that leaves, the other two acute angles in your right triangle add up to 90 together. So z is just going to be 90 minus y. All right, so we'll go back to Desmos, and we'll just do that. All right, so there is z. I'm also going to define this as z. So z is 53.13, just again approximately. Now we're just going to do the tangent of that. And this again we'll go to Desmos to do. So next line, tan of capital Z. All right, so it gives me 1.33333. Notice that doesn't match our answer choices, which are fractions, but all I have to do is just hit this little button. Okay, there it is, 4/3. Correct answer is going to be A. All right, so this is method one or approach one, we'll call it. All right, alternate solution method that you could use. Excuse me. Next, you could go ahead and notice that the tangent of angle Z is going to equal, let me just make sure I get this right, xy over xz. Okay, so in other words, if you look at the whole large triangle here, okay, tangent of angle Z is equal to its opposite side, xy, over its adjacent side, xz. All right, notice from the picture, this is basically like short leg over long leg, just the way that I've drawn it. So now, if you look at the small triangle, the yellow triangle, basically you set up the ratio in that triangle of the same corresponding sides, which is going to be right here. Even though it doesn't I'm just going based on the drawing of the picture. But it's even like it's not going to be short leg and long leg because 708 is longer or larger than 531. So basically, it's going to correspond to 708 over 531. And if you just go ahead and divide those out, you'll see that they're just equal to 4/3. See, again, it's 1.33333 or right there, 4/3. All right, so what I'm doing here is when you have a right triangle and you draw an altitude to the hypotenuse, which is what XW is, it splits the large right triangle into two smaller right triangles. All three of the triangles are similar to each other. Okay? So just to show you basically what I'm doing here. Um, so like we know that this angle is 38.86. We found it previously, but whatever. Just I'm just going to use this thing because that's the actual value. And we know this is 53.13. So what happens is this is also 53.13 and this is also 38.86. Let me just double check. Am I writing that correctly? No, it's 36.86. What am I doing? Not 38. Get rid of this. 36. 36. 36. Okay. So you have the large overall triangle. Okay. Z, X, Y. Down here you've got the 53. Up here we got the 36. Whatever, ignoring the decimals. Okay. Then we have this small yellow triangle. Okay. And I'm going to draw the same orientation. So here's the right angle at W. Notice X is down here at angle X. is the 53 angle. So X is down here and it's 53, and then Y is up here, okay, and it's 36. So notice in these two triangles, basically the tangent of Z right here, okay, corresponds to this side, whatever that's across from it, which is XY, and then over, this side down here, which is XZ. So the same thing is going to be true because they're similar. All these triangles are similar. So the sides are going to be proportional. So the tangent of this 53 is going to be the same. In other words, this side over this side, opposite over adjacent, it's going to have the same ratio as this side over this side. The values obviously aren't the same, but the point is the tangent, the ratios of the trig functions, the ratios of the sides are the same because they are all similar triangles. We know they're similar triangles because notice we have, you only need two pairs of congruent angles, but we technically have three. All right. So the whole point is the tangent of angle Z, looking at the triangle to the left, is yx over xz. Okay. xy over xz, whatever you want to call it. We can get rid of the short leg and long leg since we know that technically it's actually the opposite of that. And that will be the same as the ratio of the tangent for the other triangle. In other words, this side to this side will have the same ratio as this side to this side. Okay? And this side over this side is just equal to the tangent of z, which is what we're looking for. And therefore, it will be the same as the ratio of this side to this side, which we already know. That's the 708 to the 531. Okay? So therefore, this is an alternate method that you could use to get it by setting up similar triangles, and you get the exact same answer of 4/3. Okay, sorry, it's a long explanation to go through that and just talk about how the similar triangles work. All right, below that, we have a word problem involving percentages. So what's going on here is you have the muscle mass, okay, 134.8 kilograms, and that's equal to about 67.2% of the overall mass. So you set up an equation, 134.8 is, and then you 67.2%, convert that to a decimal, and then x is our overall mass. So you just solve this for x, divide by 0.672. And I'm going to do this all in Desmos. It's going to be just so we carry the exact values through. All right, so the overall mass, which I'm going to call M, which is going to be equal to 134.8 divided by 0.672. All right, so we have it right there. Let me just also scroll up so it's a little bit easier to see this. Okay, next. What we need to do is figure out the remaining mass taking away the muscle mass, meaning how much of the remaining mass, which is part that's divided into bone and fat, what that actual number is. So I'm just going to take the M value and subtract the 134.8. And I'm going to call this R for remaining. Okay. So again, I subtracted 134.8, and the remaining mass is just going to be equal to, again, we just need to approximate 65.79. All right, so this is bone and fat, the total mass of both. Now we need to find 56% of this to find the total mass of the bone. So we're going to multiply this by 0.566. That's going to give us the bone mass. So now I'm going to define that as B. So I'm going to take R times 0.566. Okay, so bone mass is 37.24 approximately. 37.24. That is the bone mass. Now I'm going to subtract this minus that, and that's going to give me the fat mass. Because ultimately we'll need that figure to get our final overall answer. So now I want to take and I'm going to call this F for fat mass, the remaining amount, the R, minus the bone mass. Okay, we get 28.55. So the fat mass is about 28.55 kilograms. Now we need to know the percent nearest tenth of percentage, the fat composition of the overall mass. So all we're doing now is we're taking the 28.55 and dividing that by the overall mass, the 200.959. So now I'm just going to take F, divide it by M. Remember, M is what I defined as the overall mass at the beginning. Okay, now just multiply it by 100 to get it into a percentage. So this is, let's see here, 14.2352. 14.2352. All right, so round it to the nearest tenth of a percentage, it's going to be 14.2%. So in this question, not sure if this is multiple choice or if it would be a grid in, but 14.2% is the percentage of the overall body mass of this buffalo, which is comprised of fat. All right, next question. We have one here that looks looks fairly complicated, but it actually is not that difficult. So you're given this function with some absolute value signs and whatever a and b, they're constants. You're also told that like when you plug in 547, you get some number. When you plug in negative 533, you get some other number, h and k, okay, whatever. And they want to know what's the value of this expression here. So first I will show you just how you can do this in Desmos and figure it out entirely in that, and then I'll talk a little bit about the theory for why it works out like that. Let me slide this over. Okay, so first thing I'm going to do is I'm going to define my function. Okay, and I got to add sliders for A and B. Now A has to be greater than B, and they both have to be greater than 65. So let's go 67, and let's go 66. They don't have to be integers, but whatever, that's fine. Okay. So now I'm going to say H equals F of, let's do it this way. H equals F of 547. Okay, it's some gigantic number, but it actually doesn't matter what it is. K equals F of negative 533. Just so far, notice H and K are identical. Okay, just make a note of that. I'll talk about that in a little bit. Now, okay, what's the value of 7 times 547 to the H? Hold on, I gotta type it like this. H minus K plus negative 533 to the H minus K. All right, so what is the correct answer? The correct answer is 8. All right, and you can do the entire thing in Desmos. Now, here's the theory behind this, or here's what's actually going on or what's actually happening. All right, basically, when you plug in 547 for x in these, inside the absolute value, you get 540. Okay, and then the absolute value of 540 is just 540, and then it works out the problem based on what A is and what B is and blah blah whatever, and it gives you some number. However, when you plug in negative 533, negative 533 minus 7 is negative 540. And so, but the absolute value then turns it to positive 540. So the point is, H and K end up equaling each other because you have the same, like the absolute value gives you the same expression. It's basically like A times 540 squared minus 65 times 540 plus B, and whatever A and B are. That it's the same value for both of them. Therefore, H and K are the same number. So H minus K just becomes 0, and H minus K just becomes 0. So then this whole thing just becomes 7 times 547 to 7 times 1, and then this is 0 is just plus 1. 7 plus 1 equals 8, okay? And that's basically kind of like the theory behind it. But again, you could go to Desmos, you can plug the entire thing in there. All right, next up, question number 10. Here we have two functions, and it wants to know which of these displays the y-intercept of the function as a constant or coefficient in the function for x is greater than or equal to 0, where a and b are positive constants. So For this one, the easiest way, I think, is just go straight to Desmos and graph them each out. Okay, so the first one, we'll add the sliders just in a second. Okay, so they're positive constants, so just whatever. There we go. All right, let me go back to the home thing here. Also notice you can set a restriction on the graph. So I'm going to restrict this to just, x is greater than or equal to 0, which is what the it says in the problem, basically for the domain. All right, so one of these has 4.8. The other one has 39.423. So again, 4.8, 39.423. Now, do we see, like, if I just replace the A's here with the 2 that it's equal to, and I replace the B with 2.8, 2.8, do I see a constant, meaning just a number added with no variable on it, added or subtracted in the problem anywhere? Do I see 4.8 or 39.423? No. Do I see a coefficient, meaning a number in front of a variable or in front of, like, a base constant being raised to a variable? And the answer is no, I do not. I do not see 4.8, anywhere. I do not see 39.423 anywhere. So therefore, based on, what you're given in this problem, the answer should be D, none of the above. The thing is, with most of the posts about it, it described the two things as being equal, like, but I saw that there's one or a couple other places where it talked about having wording like at most. So I think the actual, like, correct problem or solution to this, when you set it up, is an inequality, not an actual equation. Because if you do an equation, it'll come out to an exact number, and if that number is not an odd integer, then it doesn't really make sense because you're looking for the exact value that makes both sides equal. But if it's an inequality, I mean, there are multiple values, that would make that equal, but that's why it's asking for, the maximum value, largest value. So the four consecutive odd integers are just going to be x, x plus 2, x plus 4, and x plus 6. The reason is because you think about odd integers, 1, 3, 5, 7. It's not the answer, but, they're separated by 2. So that's why it's plus 2, plus 4, plus 6. All right? So now the product of the first integer and 36, so x times 36, okay, is at most, that means it has to be less than or equal to, because we're talking about a maximum. Think about at most, the maximum value you can get. 66 less than. So this means we're subtracting 66 from something. This less than is not an inequality symbol. This is indicating subtraction. Okay, the sum of, so we're adding two things together, first integer and fourth integer. That would be x plus 6. So now, if you go through, just 36x on the left side, 2x, 6 minus 66 minus 60. You can just solve this. 36x less than or equal to negative 60. X is less than or equal to, again, solving this you could also do in Desmos, negative 1.76. So that means the first integer must be less than negative 1.76. And it has to be an odd integer. So it's not negative 2. The first number you come to that's an odd integer, which is less than this, is going to be basically negative 3. So it would be, negative 3, negative 1, 1, and 3. This would be, in other words, this is the maximum value that x could be. Also, I will let you know of a similar problem to this, like a similar, wording that I saw. And basically, let me just look at my notes here. The way that this one was worded is it basically said 37 times the third integer, and I'm assuming here it would have the same at most, 68 less than the sum of the first and fourth integers. So it had the same x uh, plus 6 on the right, and then minus 68 instead of minus 66. Okay. And so then this one you could go ahead and still solve it, same way. It's just going to be slightly different. Um, Actually, 37 times 4, I don't know what that is. So I'm just going to skip the step and go to my notes here. Basically, you end up, this is 2x, so this is 37x plus, what's 30? I guess I'll go to Desmos. 37 times 4 is going to be 150 something, 148. And then you subtract 2x and you get 35x. And then you subtract, this is negative 62, and then when you subtract 148, it becomes negative 210. So you get x is less than or equal to negative 6. So that means the first integer would have to be negative 7. So in this case, it'd be negative 7, negative 5, negative 3, negative 1, but the maximum value that the first integer could be, which is the smallest or least of the four integers, would be negative 7. So this was just, and the wording for this, it said like the product of 37 and the third integer, is at most 68 less than the sum of the first and the fourth integer. So that was just basically a different variation of the same problem. Number 6 next. Basically, you were told, you're given inequality, told this represents the solution to ax minus blah, 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 blah. Find the greatest value of a. So essentially, what you're going to do here is we're going to just take this inequality and solve it, add 21 to both sides, ax less than or equal to 45, divide by a. So the solution to this inequality is x is less than or equal to 45 over a. But we also know that x is greater than or equal to 9 also represents the solution. So essentially what you're doing is you're figuring out what is the value of a to transform this into x is greater than or equal to negative 9. So, okay, what does a have to be in order to make 45 over divided by it equal negative 9? Well, 45 divided by a equals negative 9. Just cross multiply 45, negative 9a, divided by negative 9. A has to be negative 5. So, if you plug negative 5 in for a, now you get negative 9 on the right. That checks. Notice the inequality sign also flips because you're dividing by negative number. So that checks. So now we found a value for a, and it gives us the correct solution to the inequality. So that's going to be the correct answer. Correct answer is going to be just negative 5. Now we can also confirm this in Desmos. So basically, we're going to graph this inequality, and then going to graph the other one. We'll add a slider for A, and if you notice here, like it's going kind of the wrong direction. We want the two things to completely overlap, essentially. Excuse me. And notice here, oops, went too far. Right here, they completely overlap. When I plug in negative 5 for A, notice the solution sets are identical, okay? If I unhighlight this, I have this. If I unhighlight this, I have the gray. So that's what we're looking for. So that just confirms we have the correct answer. Up is a tricky problem dealing again with area factor and scale factor. So on this problem, you're told about two cubes, okay? One of them has an edge length that is 88/7 times the edge length of the other one. So, but then they tell you that the surface area of the smaller cube is basically equal to W times surface area of the larger one. Find W. Okay, so there's multiple ways you could do this. First way I'll show you is kind of the theoretical way, and then I'll show you how you could do it, the actual example out with picking numbers. Okay. X, Y, X. My 2 cubes, okay. So for cube y, so the scale factor basically is 88 over 7 to get from cube y to cube x. You know, cube y is smaller, cube x is bigger. Just right here, small, big. Okay. So the surface area of cube y, okay, compared to the surface area of cube x, essentially, you know, the to get from the surface area of the small to the big, you would have to multiply by the area factor, which is the scale factor squared. Okay, so again, the area factor here would be 88 sevenths squared because we're talking about an area factor. We're talking about surface area. Area is two-dimensional, so in other words, if the area of the bottom cube is 1, just say, then to get the area of the large cube of x, you would multiply by 88 sevenths squared, 1 times that. So just confirm this is like the small area times the area factor, which is just the scale factor squared, equals, the large area. But now they tell us surface area y is equal to w times surface area x. So you have to basically what you have to do is get this 88 sevenths squared over to the other side because they want surface area y alone and they want to know what the w is, the number is that's multiplied by the surface area of x. So essentially what you're going to do is you could divide by 88 sevenths squared, or really what you're doing is you're going to multiply by 7 over 88 squared. So the surface area of y is equal to 7 over 88 squared surface area of x. So now this is the number that corresponds to the w. So the w value is going to be 7 squared over 88 squared, which is 49 over, just make sure I get this right, 46464. 49, 46464. Just confirm that in Desmos. No, not the right number. I had an extra 6 in that. Never mind. Sorry. It should be 7694. No. 7744. I'm looking at the work for the example I did using picking numbers where I actually multiplied the things out by 6. So now, because this is too big, if this was a grid in, thing, too big to fill in. If it was a multiple choice, obviously you'd, look for this fraction and select it. But if it was an actual, student-produced response you could fill in, well, you just have to go to Desmos and just divide, 49 by 7744. And so you could either fill in 0.0063 as the decimal, or you could do 0.006. That would either of those would fill up all 5 spaces. Okay, so this is the theoretical explanation behind it. Now what I'm going to do is I'm going to actually do it out picking some numbers and just showing you, using actual numbers how it works out. So let's say cube y has sides 1, 1, and 1. Okay, therefore the surface area for y is going to be 1 times 1, the area of one face, and then just times 6 because they're all equal because it's a cube. Okay, so total surface area for y is going to be 6. It means the sides in cube y are all going to be 88 over 7. 88 over 7, but well, 88 over 7. So the surface area of x is just basically 88 over 7 times 88 over 7 and then times 6. So if you multiply this whole thing out, it turns out to be 46464 all over 49. So now you can basically go set up the equation. Surface area of y equals w times surface area of x. And now you just solve this for w. So you're just going to basically multiply by the reciprocal here, 49 on top, 4, 6, 4, 6, 4. Do the same thing over here, times 49 over 4, 6, 4, 6, 4. And that's going to give us our value for W. So notice if we go back to Desmos here, as we got 49 on top, 4, 6, 4, 6, 4, okay? And that's being multiplied by 6. So that is our value for W. Notice we get the exact same answer that I had above. Or if you want to just confirm in the fraction form, notice again, it's the 49 over 7744. Okay, so decimal form, fraction form, but we get the same answer. It's just here I'm technically plugging in actual values for the surface area of x and y and then solving for x, or for w, excuse me, based on those values. So we get the same, basically the same answer. All right, next one. This is a problem that had like basically a large triangle and then a bunch of lines and different angles in it. And uh, most of the information was provided for it, but the one thing that I did add to this, because I think you do need to know this, is that DE and AC are parallel. I don't think there's any way to prove just from everything else, but you basically know in the picture that um, OA and OB are equal, and you know that these two sides here, AB and AC are equal. And you also know that this angle is equal to 30 degrees. And you know AB, this side over here, is 58. What's the length of BE? So basically what ends up happening here is this overall triangle ends up being split into two congruent triangles on the left, ABF and CBF. So that means all the angles and sides and everything are going to be equal. So technically, like we can find the length of BD, and then we can just set, and then basically BE is going to be the same as that. So here's what we know. And another reason you have to know DE is parallel to AC is that if this angle is 30, then this angle right here is 30. Okay. These will also be perpendicular because up here B is equidistant from the endpoints of this line segment AC. That's why AB and AC are the same. Therefore, B will be on the perpendicular bisector of segment AC. So that's how I know that it's going to be perpendicular to this right here. And then because DE and AC are parallel, well, this is corresponding angle. This is also a right angle. Okay. So then what happens is basically, notice this whole angle becomes 120. So now what you do is you split this up like this whole large triangle into two triangles, and the two triangles end up being congruent here. And the reason is because you have a pair of angles here, you have a pair of angles here, you have two right angles, and then you have one pair of congruent sides right here that's shared. So AAS. So these two triangles, let me just pick a different color here. So basically this triangle here and this triangle here will be congruent to each other. So let me just highlight, let me just kind of separate out here. So we know also the following. Because this whole side is 58, if I make two congruent triangles, that means that A to this point, I don't know, we'll just call this point P. For AP to BP, these two sides have to be the same because the two triangles are congruent. So that means it's going to be split up here 29 and 29. Okay? So therefore, this is going to be 29. This is A, this is point P, this is O. I also know, let's see here. Oh, you also know that because this whole angle is 120, okay? If you subtract that from 180, you get 60. And then this angle at the top and this angle down here at the bottom will be congruent. Because if you look at the overall large triangle AOB, these two, let me just pick a different color. Let me use red here. These two red angles are across from congruent sides because they're across from OB and OA, which are congruent. Therefore, the 60 gets cut in half and they are each 30. So this is also 30, and this is also 30. So that means down here, I know this is 30. Therefore, I know this also has to be 60. So what that allows me to find now is I have right here this side's across from the 60. So this is the long leg. And again, you could do this using trig if you wanted to. I'm just using the 30, 60, 90 kind of shortcuts. So to get from the long leg to the short leg over here across from the 30, I'm just going to do 29 divided by root 3. And uh, then to get from the short leg to the hypotenuse, I'm going to multiply this by 2. So this is going to be 58 square root 3. Now, or 58, excuse me, divided by root 3. And now you could also rationalize this by just doing times root 3 over root 3. So really it's 58 root 3 over 3. Okay, that's for OA here. Now, therefore, because again, these two triangles are congruent, the two green ones, that means that OB is also equal to 58 root 3 over 3. So right here, 58 root 3 over 3 for OB. So now what you can do is you can, let me see which triangle I looked at here. I know 58 root, okay. So now you can just look at either of these two top triangles. So like let's say we look at the one on the right. Or actually, let me look at the one on the left and then like I said, I know that because it makes two congruent triangles. So we have B up here, we have O here, and then here we have D. So this is 58 root 3 over 3. I know this angle is 30 degrees, therefore this angle has to be 60 degrees. So this is across from a 60-degree angle, so this is the long leg. To get the short leg using the 3069 triangle right triangle properties, I have to take this and I have to divide it by root 3. What's going to happen is the root 3's are going to cancel and I'm going to get 58 over 3 for this side, for DO, right here. That's the short leg. To get to the hypotenuse now, I multiply it by 2. 116 over 3. That's going to be the final answer because, again, basically you have two congruent triangles up here, BOD, BOE. Again, because the whole thing is split basically down the middle, into two congruent triangles. Essentially, because they're both right triangles, and you can use HL, hypotenuse leg. You have the right angles here, you have the shared leg, BF, reflexive property. It's the same in both, and then you're told AB and AC are congruent. So that's how we know the two overall are congruent, and therefore that would lead to these two small here also being congruent. So BD is going to be the same as BE. Therefore, this is the correct answer. It's 116 over 3. You could also, if you had to grid this in, you could also put 38.66. You could also put 38.67 if you round it. First one is truncating it. This is a long problem. This is a complicated problem. Maybe there's more information that it's given. The students didn't remember, and therefore makes it a little easier, shorter, quicker to do. But just based on what was provided and what I think that you were given, this is how you would solve this problem out. Last question number 10. So this is an alternate solution method. Again, this will hopefully be a little shorter, a little easier to understand than possibly the original method that I went through. So this right here, okay, we know is 30 degrees. Again, AB, this whole side is 58. And the other stuff will some of the other stuff will come into play a little bit later. So notice down here, this is perpendicular. Okay, basically you have a 30, 60, 90 triangle. Okay, so the sine of 30 here, 30 degrees, sine of 30 is equal to OF opposite over OA, hypotenuse. Sine of 30 is also equal to 1/2. Okay, you can just do that in Desmos if you don't have it memorized. So if you rearrange this, the side OF here is equal to basically OA over 2. Now, OA is also equal to OB because that's given information right here. Okay? Or an alternate way you could also rearrange this is you could say OA is equal to 2 times OF, just multiply by 2 on both sides. So what that means is if this is x, right, then OA would be equal to 2x. Well, that's just 30, 60, 90 triangle properties, right? Short leg to hypotenuse, which means this is also equal to 2x. Now, here's what you do, and this is the whole key to the whole problem. If you look at BO, if you look at the top triangle, okay, BDE, specifically look at the height here, BO. That is, say, 2x. Then you look at the large overall triangle, BAC, okay, and you look at this. This whole thing here is 3x. That means the ratio of the small triangle to the large, again, so small triangle to large triangle is basically 2x to 3x, or really it's just 2 to 3. The x part is irrelevant. It's the 2 to 3 part is essentially what we're concerned with. So what that means is any side in the small triangle is going to be equal to any is going to be have a ratio of 2 to 3 to any side in the large triangle. So AB is 58, BC is also 58. Told AB and BC are congruent. All right. So small to large ratio is 2 to 3. So small triangle side is BE. That's what we're trying to find. Large triangle side is 58. Okay, I'm comparing this to its corresponding side here in the large. And again, I just determined the ratio is 2 to 3. So now you can just solve this for BE, multiply by 58. 58 times 2, 116 over 3. We get the same answer that I got working it out, using the other approach, the other method, but this one is, much shorter, much easier, fewer steps. But basically what you're doing is essentially determining the ratio of the small triangle on top to the large overall triangle because they are similar triangles. And then that ratio is what allows you to figure out, BE in relation to BC, and therefore solving for BE or getting the answer. All right, so let's go ahead and get started now with question number 1. So this one looks like a fairly complicated problem, and it is because you have to set up the diagram and everything, but once you do that, it's actually not that bad. So what ends up happening is we have an isosceles triangle, okay, where AB and AC are congruent. So I'm going to put A up here, I'm going to put B here and C here. Okay, so these two sides right here are congruent. Also means that this angle is congruent to this angle, angle B and angle C. That'll come into play later. Now, point D is on side BC, so down here, what we call the base, where DC is 5/7 of BC. So that means 5/7, notice, is more than half. So that means that point D is like more than halfway over here. So maybe it's like right here. Okay. And then we also have E being placed on AB. So whatever, I'll just put it here. F being placed on AC such that angle BED, so first I just have to connect E to D here, and DFC, so I also have to connect D to F here, are congruent. Okay, so for example, now we know that these two angles here are congruent. All right, one more piece of information we're given, DE is 10. So that's everything that's provided so far, in the problem, and now they want to know what is basically the length or the value of DF. So what actually happens here is these two triangles that I made at the bottom, BED and CFD, they are similar to each other because there are two pairs of congruent angles. So by the AA similarity postulate, i.e. we have two pairs of congruent angles. Basically what we know is that EBD is going to be similar to, and I got to make sure I get this in the right order. So I start up here at E, which is angle congruent to it is F. Then I have to go to C, and then I end at D. Okay? So now notice that uh, DE and DF, those are going to be corresponding sides. So it's whatever the scale factor is between the two triangles, that's going to help me get, from DE to DF or, vice versa, however you're looking at it. So what you know is the following. And I'm just going to make up some numbers here just to make it easier to work with, but BD is 5/7 of BC. So what that means is, say, just hypothetically, this whole thing was 7. 5/7 of 7 is just 5. So like this thing right here would be 5, and then this over here would be 2. So the whole key here is now we have the scale factor between the two triangles. Basically, it's like they're in a ratio of 2 to 5. So it's like if you look at the small one, the side is 2, to the large side is 5, CD to BD. And then that's going to be equal to the same proportion or same ratio as DF, which we're solving for, to DE, which is 10. So now you could just solve this. You could just, you can cross multiply, or you could just multiply by 10 on both sides. And like 5 goes into 10 here twice. 2 times 2 is 4. So DF in this example would just be 4. Okay, so your correct answer would be 4. Now, the fact that I chose 7 here that doesn't really matter. I just chose that to make the nice, easy numbers to work with. Technically, if you want to split this up, it's like this is 5/7 of whatever x, your total side length here is, and this would be the remainder, which would be 2/7. So you could say 2/7 x. So even if you use those values, it's like 2x over 7, 5x over 7. Like, if you just reduce this down, the 7's cancel out, the x's cancel out, and you still get the same ratio or the same scale factor of 2 to 5, looking from small to large. Okay? And that's basically the key to figuring out the problem. Next up, we have a problem which basically appeared to be kind of brand new to this November test. I think on the test, the way this one, it was actually given as a picture, not given as coordinates like I did it. Meaning the actual problem had a picture here with the line segment, but it's still the same basic idea, same basic principle. So you have one side of a triangle, and it basically is at like -2, 3. Let's say where this is, and then it ended at like say 5, 10. These are just numbers I made up. And then you were told the area of the triangle, and I want to know what is the length of the other leg. So all we're doing is basically, you know, using the area formula, 1/2 base times height. We know the area is 20√2. And then the base, the height is what we're going to solve for. The base, here we're just going to use the distance formula to find the distance between these 2 points. Now, if you want to, yeah, you could do like 5 minus -2 squared plus 10 minus 3 squared, and then do all that workout and everything. But who wants to do that? We can just go to Desmos. And we can just use the distance formula with our 2 points. Now, the problem with this is it does not give us, it gives us an exact value. I'm just going to define this, by the way, to be b, our base. It does not give us like the nice radical value, which is what you would get if you actually do it by hand. Because if you do this by hand, it's going to be the square root of 98, which just simplifies to 7√2. So if you do it by hand, you get 7√2, and then that just plugs in here. And notice what happens is, oh, I forgot the 1/2. Need the 1/2 out front. The root 2's cancel. You multiply this by 2. You divide by 7. So the height in this case just ends up being 40/7. And now you could, of course, put that as a decimal equivalent, 5.714. Or maybe it's multiple choice, it only has the fraction, who knows. If it's free response, of course, you could also put the 5.714. Now, I will say, then what you would do, if you found the distance in Desmos, okay, using the distance formula and you defined it here, then basically you're just setting up a basic equation, right? And you're just doing the area, which is 20 square root 2 equals 1/2, and then times b, which is going to carry the value down from above. And then here I'm just going to put x. And so here it gives me 5.714. But again, if we want to know the exact value, maybe more exact value, maybe I would do regression and just do it like this. And now here it's 5.71429, so it has to be 5.714. I don't think if you just type 5.71429, yeah, it's not going to give you, yeah, it's not going to give you the nice 40 over 7, unfortunately. Basically what you'd have to do is you'd have to take, basically essentially do what it did by hand, which is take the 20 square root 2, multiply it by 2, divide it by 7. Let's see here. Yeah, multiply by 2, divide by 7. And then why is it not giving me, let's see here, what's its times 2. Let's try this again. Oh, I need, sorry, I'm doing this incorrectly. I need to basically do, sorry, it's 20 over 2 just going to be divided by b. Times 2 and divided by b is what I need to, excuse me, is what I need to do. Times 2 to make up for the 1/2, and then here's where b goes. Okay, so now this is actually solving for the height, and now if you click this, okay, now we have 40 root 7. So again, what I was just doing is like I had 20 root 2 equals 1/2. This is the b value that was stored in Desmos, and this is h. So to solve this for h, again, you're just doing times 2 and then dividing by b. So this is what you could type in to Desmos to get the exact value. Looking at this next problem now, number 7. So this one is basically one where there's actually essentially just like a little trick that you use to figure it out. The shortcut formula or shortcut method for when you see a problem like this, which is essentially in the form of a quadratic, and you're trying to figure out the maximum value of b, given that it is factorable, meaning that there's at least one real solution, is it's basically just a times c plus 1. So the answer is going to be 34 times 50 plus 1. Okay, so let's see. This is basically going to work out to, I believe, 1701. Yep, just 1701, and that's it. Now, just to show you why essentially it works out like that. So if you figure this is going to be z to the ninth, this is something z to the ninth, this is going to be plus, this is going to be plus. Okay. So it just works out that when you're thinking about factors here, so like in the first spot in each parenthesis, it's going to be factors of 34. Second spot's going to be factors of 50. The way that you get the maximum value is by basically putting here 34 and 1, and then here 1 and 50. So that when you go ahead and FOIL this, right, for the b terms, meaning the inner and the outer terms, when you think about FOIL, basically for these two terms that combine to make the b term, the inner term right here, we've got 1 z to the ninth, outer terms, the 34 times 50. And you can fool around with all the different combinations, but this is going to be the largest possible value that you can make, right? So it's going to be 1 plus 1700, which is the 1701. And that's basically your answer. And again, this is the little shortcut to know for this type of problem. All right, the next question. Here we have a circle, equation of a circle, and they tell us what the radius of the circle is, and they want to know what the value of t has to be in this. So first I'm going to show you how you could do this by hand, and then after that I will show a Desmos method, but it's not entirely done in Desmos. You do have to do a little bit of manipulation first. So essentially what you're going to do is you're going to go through the process of putting this into standard form. So first thing you do is divide everything by 2, and you get x squared plus t over 2x, and then we're going to put a blank, and then we get y squared plus t over 2y. Now, this becomes negative 30, and I'm just going to add that over to the right, and we have two blanks over here. Okay, so now if we were going through the process of completing the square, basically the way that you're going to think about this is that um, you need to make 38 on the right side, right? Because if the equation is equal to 38, then that's the r squared value in the standard form equation of a circle, y minus k squared equals r squared, and then r would just be the square root of 38. All right, we already have 30. That means we need to add 8 to that. So these two blank spaces basically together need to add up to 8. And they're going to have to each be 4 and 4 because we have the exact same values here, like, for the t's and everything. It's t over 2x and t over 2y, which means it'll be the same number in the blank. If one of them was just t over 2x and the other was ty or 2ty, then they could be different. It could be like 2 and 6 or whatever. But because everything's the same, that's how I know it's got to be 4 and 4. So if you go through the process of completing the square, the way it works is you take the b value, t over 2. Okay, so that's equal to b. Then you take half of it, meaning you divide it by 2. So that becomes now t over 4. Then you square that, and that value, which is t squared over 16, excuse me, that's technically what's going to go in the blank here. It's also what's going to go in the blank here as well. So we need these to each equal 4, which means t squared over 16 must equal 4. In other words, t squared has to equal 64. Therefore, you square root both sides. T has to equal 8. So the correct answer for this is going to be 8 for the value of t. Now, we can just go to Desmos and confirm this. Not solve it, but just, confirm that this is the correct answer. So I'm just going to type in the circle. I'll just fill in the values. Okay. For t, just type in 8. Okay. So now I'm going to click the max and min points, and I'm going to find the distance between these 2 points, which is, and then that'll be the diameter value, and then technically I'm going to divide that. So it's -2, 4.164. Okay, and the other one is -2, comma, negative, let's see here, something, -8.164. So this is just the diameter value, top to bottom. So if I divide this by 2, now I get the radius. So I just want to confirm that that is equal to the square root of 38. And it is. I mean, obviously it's not exact because I didn't have exact values for the points here, but you can see it's close enough. 6.164, 6.164, blah, blah, blah. Okay, so that just confirms it's correct. Now, the way you could do this in Desmos, okay, it requires a little bit of work or a little bit of knowledge. My experimentation, you have to basically uh, set the two equations equal to each other using regression. But the original expression that you're given here has to um, be divided by 2 first. So what I mean by that is if you just try to type this in, okay, so now we're going to set this equal to basically essentially the standard form equation. And the whole key is that we want this, the standard form equation is basically going to have this, 38 in it because we want the radius to be equal to 38. So I'm just going to do this. All right, so now right, because x minus h squared plus y minus k squared. Okay, and then because you would subtract 38 over and it would be equal to 0. Now what we have to do first is we have to define x1 as a list. Okay, we also, because we have second variable, we also have to define y1 as a list. Okay, so if you notice here, what happens is when I do that, it does not give me, it technically doesn't give me the correct values for t, h, and k. The h and k part I'm not so concerned about. It's more the t value that basically I know is wrong. And if you see here, even if I add more, things, it's not giving me the correct value for t. However, okay, if you edit this and you divide everything by 2, now, okay, so here's the full regression statement. If you divide the original function that you're given by 2 and use that form on the left side, notice now it gives you the correct values for h and k, and also more importantly for t. And it gives you right here, let's see though, it's technically giving us uh, -8. The only problem I just noticed is when you do the square root here, technically it could be plus or minus 8. Um, so I guess in this problem, the way that it would have to be worded, or because both positive and -8 would work. Essentially, one of them is a circle with the center at like 2, 2, and the other one is one with the center at like -2, -2 down here. And then, but they each have the same radius. You know what I'm saying? So if you look at it in standard form, it's either going to be like both can be equal to 38. It's going to be x plus 2 squared plus y plus 2 squared equals 38, or x minus 2 squared plus y minus 2 squared equals 38. So either would be correct. Um, so I'm assuming that the way this problem is worded, and I'll probably change this language on the final PDF file, is that uh, t is a positive constant or negative, or it could be, I guess, negative constant, either one. So, because technically you're getting two answers. However, if you go back to the regression statement and we put in this qualifier, okay, see now this gives me the equation that I had originally where I just assumed that t was positive. T is +8 and the h and k are both -2. That's the circle that's like down here. That's the one that I had the graph of. Um, Not sure why it turned it into a square. Anyways, so I'll probably change the wording of this to define that t is a positive constant, but this is how you can do it in Desmos using regression. It's just for some reason, and I haven't figured out, exactly why yet. You have to basically divide everything on the left by 2 compared to the right. I guess so it's just x squared and y squared instead of having like the 2's in front of them because those basically mess it up. Okay, so starting with the first one, this was a pretty popular problem for discussion, and it was basically something about there were two different whatever, I think it was mostly animals and different the different problems that were out there, and it was asking about what you need to do to design a study to ensure that you can determine a cause and effect relationship between, whatever, a certain diet or some type of treatment that would be applied to these, two different types of animals. So the correct answer for this is going is going to be letter D. Basically, random assignment of the items that you select or choose to be in your study to both treatment and control groups is how you ensure that there's a cause and effect relationship, or in other words, what makes the study valid or determining the effect of the treatment valid. Okay. Let's see here. Letter A, which is just randomly selecting the pigs and hogs or whatever the animals are, is what you do if you want to generalize the study to the largest population possible. Okay, so random selection is what allows you to generalize a study to a larger group, which obviously it's not the correct answer for this problem, but I'm just telling you so that in general. Whereas random assignment is what allows you to determine a cause and effect relationship, or essentially ensure that the study is valid in terms of determining the cause and effect of a treatment. Okay, the next question is a repeat question that we have seen before. So basically, you have this rectangular region, right? And it's divided into a bunch of small squares. Each of these small squares has an area, usually of capital R. And then you're told that the length is 2.5 times the width. However, you also know the width is equal to x root r. Okay, so this right here, this is intended to be the width. Now, the length is just going to be 2.5 times that. So in other words, the length is going to be 2.5 times x root r. So the way that you solve this now is you say, okay, area rectangle, length times width. So that is 2.5x root r times x root r. The root r's just become r, x becomes x squared. You get a 2.5 in front. Then you set that equal to what the area of the rectangle must be based on this first sentence, specifically this information right here. Each square has an area of r, and there are 90 of them. So the total area is also going to be equal to 90r. Then that causes the r's to cancel out, and then you can just divide by 2.5, and that gives you x squared equal to 36. So the value of x is just going to be positive 6. Of course, once you set up the equation here and you cancel the r's out, I mean, you could just type that in Desmos and get the answer that way as well. But the correct answer for this problem is positive 6. All right, so for this problem, because it is infinitely many solutions and the constants are, there's technically 3 different constants in this problem, but because at least one of them is in a constant term, meaning a number term, not for an x or a y term, basically can't use all of the various methods that I've covered with regards to finding the value of a constant for a system of linear equations. All right, instead we can use the ratio method, or we can also use the SI form method. So I'm going to demonstrate those. Then after that, I'll also show you algebraically, or by hand, how you could get the answer as well. Okay, so if we're going to use the ratio method for this, notice g and k are both constant terms. So I'm going to have to use basically the x coefficients, and I'm going to put x top over coefficient of x on the bottom. And that has to be equal to also the ratio of the number term on the top, which is g, to the number term on the bottom, which is k. So if you see here, this actually just gives us the answer right away. Basically, the answer is really just 1/2 divided by 2/9, right? And that just works out to 9 over 4. See, it's 2.25. You can just do g over k. Yeah, 9 over 4. So that is the shortest, quickest, fastest, easiest way to do this. However, if you wanted to do this using what I call the SI form method, which is get both into slope-intercept form and then do regression to equate them. So on the top one, I would do g minus 1/2 x1, and then that whole thing is going to be divided by 9/2, the number multiplied by the y. Okay, and then on the right side, we have the bottom equation, which is going to be k minus 2/9 x1. And now I had a parenthesis in here. Divide that by h. And now we do need to make sure that we put in an element list for x1. Okay, so now what's our ratio of g over k? All right, it's 2.25. So notice we get the same exact answer. Now, one thing I do want to mention, just to be clear, is that the ratio method, which I did first, gave me the correct ratio, but the values it gave for g and k are not necessarily the correct exact values. Here, these are actually the specific correct values for g and k, and also technically for h as well. So just be aware of that. The ratio method will give you the correct value for a ratio of constants, but not necessarily the individual exact values for them. So here we have a problem where you're given two linear equations, basically a system of equations, but there's multiple constants in it. They want to know the value of g over k. And specifically, you're told that this system has infinite solutions. So here is you could try to solve this with sliders on Desmos. I mean, I wouldn't recommend it because this is most likely a free response question, not multiple choice. The fact that allows you to solve this or to determine this is when you have a system of equations and they're both in, essentially standard form. The ratio for infinite solutions, the ratio between or the multiplier between like the x terms and the y terms and the number terms are all the same number, the same value. So what that means is like if you take 1/2 divided by 2/9, that will be equal to the value of g divided by k. Like basically when you have an infinite solution system of equations, like here's a really simple example. X plus 2y equals 3, 2x plus 4y equals 6. We go to Desmos, we graph these out, you're going to see they're the same line. Like notice, first of all, if you do it in terms of multipliers, like this is times 2, times 2, times 2. Or if you do it in terms of like divide ratio of coefficients, here it's 1 over 2, 1 over 2. Here it's 2 over 4, which is just 1 over 2. Here it's 3 over 6, that's 1 over 2. So that principle, that idea is what allows us to easily solve this. So g over k is just equal to 1/2 divided by 2/9. You could go to Desmos if you don't, realize that I'm just doing the fraction division here. This is going to work out to be 9 over 4, or you could also enter it as 2.25. So either one of those would be acceptable, but that's it. That's for the answer. You don't need to do, you do not need to do any more work than that. All right, last question. You have an expression here, and it tells you that it can be factored two different ways. One way with positive integer factors and one way with negative, or not negative, excuse me, with positive non-integers, meaning they're decimals or fractions. So, okay, factoring it the first way is relatively easy. I mean, you can just do trial and error, or we already know it's going to be 3x, plus something, and 2x plus something. Or excuse me, squared. 3x squared plus something, 2x squared plus something. And so it works out that it is 13 and 5 because this is 26x squared, this is 15x squared, 26 and 15, 41. Okay, so basically now we have A, we have B. Okay, A is 13, B is 5. Now, getting these other ones is tricky or is challenging. So here is the only way that I have figured out to do it. There might be other methods, but this is the only way that I've figured out. Basically, here, and I'm going to focus on like this using C and D, okay? We know that C times D has to equal 65 just because of the way the FOIL works out, right? The last two terms. And we also know that 2 times C plus 3 times D has to add up to 41 because That's the inner and outer terms together, basically make the middle term here. So what you do is you set up this system of equations, and then you solve this for C or D. I mean, really, we only want C, so I would technically try to solve it for C. However, I would not do this by hand. I'm just going to go ahead and go straight to Desmos and get it that way. And technically, you're going to see this is going to give us actually A and B and C and D. So you don't even need to factor um, the first one on its own. You can just get the answer from basically solving this system of equations because there'll be two intersection points. The other thing is, of course, we're not going to use C and D. We're going to use X and Y in Desmos. So, okay, here are my two intersection points. Here's one, here's the other. Notice this is 13.5, okay? And X is first, which corresponds to C in this problem, or A in the first expression. So it just confirms A is 13, and also the Y coordinate is 5. So 13.5, we already had that, just confirms it. Now we know C is 7.5 and D is 8 and 2/3, 8.666 repeating. Doesn't matter because we don't need it for the problem. But again, I'm looking at the intersection points from this system of equations. So what is A plus C? Well, A plus C is 13 plus 7.5, which is 20.5. So the correct answer, you could fill it in as 20.5. You could also fill it in as 41/2 as well. Just let's see here, 20.5, just to confirm. Yep, 41.2, another also acceptable form. Now, you can solve this problem entirely in Desmos because Desmos will do the factoring for you. So what we're going to need to do is basically go to Desmos, type in the original expression, and we're going to do it as a regression statement. We actually don't need the parentheses here, but whatever, I can just leave them because it doesn't make a difference. And now we're going to do one set of factorization. Now we need to add an element list for x1. Okay, so notice here it found the integer values for a and b. A is 13, b is 5. Okay, great. Now, to get the second factorization, there are technically two ways you could do this. I'll show you them both. First, I'm just going to duplicate this line up here. So one approach would be to switch the order of the parentheses. So in other words, I'm going to put the 2x squared plus d parentheses first and the 3x squared plus c parentheses second. Notice now it finds the value of the other set of factors, the non-integer factors. Therefore, you can now go ahead and you can just add a plus c, and you can get 20.5. Notice it, for whatever reason, it doesn't give me the fraction here, but you could just type 20.5 in if you want to convert it to a fraction. But in any case, we've got our correct answer. Now, an alternate approach that you could do, again here, let me get rid of this, is if you duplicate this, you can now put in, let's make this C and this D. And notice it's returning the exact same values, right? The integer values. You can put in a constraint. Let's make C less than 13. And notice when I do that, it gives me, again, the correct integer values here. And now you could go back and you could add A plus C. All right, and we have 20.5. So this is how you could do this, how you could solve this problem entirely in Desmos. It started on the first question here, where we have an exponential function. They tell us that it passes through these 2 points with a constant of c in them, and they want to know what could be the value of b. So first I will show you, I guess, what I would consider the traditional way to solve this. And then after that, I'll show you the much quicker, easier, faster Desmos method. So the traditional way to solve this would be plug in these 2 points. So for example, the first one, you would get 8. You plug that in, for your f of x or your y. And then you've got a to the c minus b. And then when you plug in the second point, you've got 190 equals a to the 2c minus b. Now, at this point, what you can notice is that if you solve this first equation for a to the c power, it turns into b plus 8. And now you can go to the second equation and you can replace a to the c with that. And the way this is going to work is a to the 2c is just the same thing as a to the c quantity squared. If I just rewrite this, because when you raise to a power, you just multiply the exponents. And now you can substitute in for a to the c the b plus 8. So that's going to be squared. Okay, then you're going to FOIL this out. So it's going to be b squared. I'm just going to skip some of the steps. It's 8b plus 8b is 16b, and then plus 64. And we still have the minus b at the end here. Now, if you get everything over to, let's say, the right side, and we get 0 equals b squared plus 15b, and it's going to be minus 126. Now you can solve this either by factoring it, or you could at this point go to Desmos and just punch it in and see what the x-intercepts or the zeros are. I'll just show you. It's going to factor as b plus 21, b minus 6. So you get b equals 6 or b equals negative 21. Okay, negative 21 is not one of the answer choices. It is 6. So the correct answer for this is letter A, 6. Now, here's how you could do this in Desmos. And again, this will be so much quicker and so much faster. All right, just want to shrink this down a little bit so we can get the problem and the graph on the screen. All right, so first thing I'm going to do is I am going to enter in a table and I'm going to put in these 2 points. Now, I'm using C, but don't worry about that. I'll talk about that in a second. Next, I'm just going to do a regression, specifically just exponential regression. So the exact format that the function is given in. Okay, so I've got c comma 8, 2c comma 190. Those are my 2 points. I've got a slider for c, which I'll talk about in a second. Okay, now I have my regression statement here. Okay, and it gives me a value of b equals 6. Now, this is for c equals 1, but what happens if I change c to a different number? If you notice what happens with the shape of the graph, the a value is what gets adjusted. The b value never changes. The b value is fixed at positive 6, okay? Even if I go all the way here to 10, even if you go into the negatives, the b value is still fixed at 6. Essentially, the b value, like the 6 in here, in the actual function, it's minus 6, which is serving as a horizontal asymptote. But anyways, this is how you could do this in Desmos. You just use a slider for C, and then you can just move it around, just confirm it says it's 6, and that's the answer. Okay, next up we have, I think this is a repeat question that we've seen before. But basically, what's going on here is we have a right triangle. Okay, B, A, C, B is the right angle that's given. AC is 35. AB is 11 less than that, which means it must be 24. And then we have a perpendicular line segment, essentially an altitude, drawn from point B to the hypotenuse, and it intersects the hypotenuse at point D right here. What's the ratio of BC to BD? This one is done using similar triangles. And essentially what happens is when you have a right triangle and you draw an altitude to the hypotenuse, from the right angle to the hypotenuse, it makes 2 new smaller triangles, and all 3 triangles in the picture are now similar to each other. So the 2 smalls and the 1 overall large, they're all similar. So what you have is basically, okay, a large triangle right here. I'm going to draw them all the same orientation, which is much easier to understand. Okay, so we've got this. Then the other triangle that we're looking at will have BC and BD. So it's going to be basically this triangle right here, but I'm going to orient it such that the corresponding sides match up. The way I can just confirm that I do that properly is, say this is 50, right? Angle A. That means this has to be 40 because 50 plus 40 is 90 and 90 plus 90 is 180. It would also mean that this is 40 and it would also mean that this is 50. So now when I match things up, I need to have, first of all, D is going to be here because D is the right angle. And then remember I said this is 50 and I said this is 40. So now in this picture of this triangle, the yellow triangle, okay, the 50-degree angle corresponds to B, which matches up with A. So the 50 has to go with the 50, so B has to go where A is, and the 40 has to go with the 40, which means C goes where C is. Okay, so all I did is I took this and I basically kind of flipped it over. So now it looks the same as triangle ABC. So BC to BD, basically hypotenuse, which is BC, to, I'm just going to call it like, side opposite 40, opposite the 40-degree angle, right here. So the ratio of these two sides, since they're all similar, will be in the same ratio, i.e. proportional to the same corresponding sides in the other one. So in other words, in ABC here on the left, the hypotenuse, which is AB, is 35, excuse me, AC, which is 35, and then the side opposite the 40, which is AB, is 24. Therefore, the correct answer to this problem is 35 over 24. You could enter it like that. You could also enter the decimal equivalent, which should be 1.458. Let me just double check that in Desmos. Make sure I'm not misreading my handwriting. Yeah, 1.458, and whether you round it or truncate it, it's going to be the same regardless. Okay, so again, this is how you solve this problem using similar triangles. All right, next up, number 6. This one is actually a tricky one when you first read it, but when you think about it, it actually is not that difficult to figure out. So you're told about this polynomial function. It has 4 x-intercepts, okay? These 4 points given here. So 4 zeros, 4 roots, however you want to think about it. So q, which is a constant, is equal to the y-coordinate of the y-intercept, and r is equal to the product of the roots. Okay, so essentially the way that we figure each of these out is, okay, r is straightforward enough. The roots are the same as the x-intercepts you see here. So you're just taking -7, -4, 2, and 3. Okay, you're just multiplying them all together and you get positive 168. For q, the only way that I've been able to figure this out or think about this is basically if these are x-intercepts, then when you go to write the function in intercept form, basically you can write its factors like this, right? Because x plus 7, that factor corresponds to an x-intercept of x equals -7, right? Because if you set this equal to 0, then you have to subtract 7 over, and that's where the -7 comes from, and so on. Basically, it's the opposites, of all the things you see here. So now, if you're going to find the y-intercept value, that just means for every x, you plug in 0. So notice what you end up doing here is for the y-intercept value, you technically end up multiplying the values. It's like the same numbers as the intercepts, except obviously the signs are opposite. So it's 7 times 4 times -2 to -3. So it's like the same numbers, but because there's an even number of negative signs, basically there's 2 of them, it's going to be positive and it's also going to be 168. So now you just add these together. Correct answer is just going to be 336 for this one. Okay, now the problem is I'm assuming that in the actual problem on the test, there's like, I don't know, there's some wording or some description or something that tells you that like there's something about like the, a leading coefficient out here, because for this polynomial, if there was like a 2 or a 1/2 or whatever, any other number out here, obviously that would be multiplied through by all these numbers, and that would change this value. So there's got to be some wording in the official test question, this appeared on the exam to basically tell you that like I don't know, the leading coefficient is 1 or something, something like that. Or they gave you some generic general form which had like x plus p, x plus q, x plus r, x plus s or something, and it just, there was just an invisible 1 in front of it. All right, let's go through this next problem. Number 7 deals with an isosceles triangle. Basically ABC. Total perimeter is 90. AB and AC are the same, and you also know AB is 35. So that means that AC is 35. Also 35 and 35 is 70, and you subtract that from 90. That means that this has to be 20. You're also given the height of this triangle, and we want to know, well, what is A? So all we have to do is drop down an altitude here. Technically, it's going to split this into two congruent triangles on the left and right, meaning that this is going to be 10 and this is going to be 10. And then we just go through, and there's multiple ways you could do this. So the way that I actually did it was I said I made this 15 root A, and then I set up Pythagorean theorem. 15 root A squared plus 10 squared equals 35 squared. It's going to be 1225. 10 squared is 100. This 15 squared is 225. Root A times root A is just A. And then I just solved this equation for A and got my answer. So 225A is going to equal 1125. A is going to equal 5, just dividing by 225. So that's your answer. However, an alternate way you may want to do this, just what may seem more obvious to you is if you just label this x and then you do the x squared plus blah, 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 okay? So you would get x squared equal to 1125. And then you would have to basically simplify that into 15 root a, meaning x is really the square root of 1125. And then you'd have to realize that 1125 obviously has a factor of 15 in it. So you'd have to go through and say, okay, 1125 divided by 15, that's 75. Okay, 1575, and then you'd say 15 and 5. Okay, now I know that this simplifies to just 15 root 5, and then you could say, okay, well, that's obviously A has to be 5. So if you wanted to do it that way or think of it that way, that's perfectly fine. Again, you get the same answer. It's the same, general approach using Pythagorean theorem, but, just a slightly different way to think about it or approach it. You can see the problem on the screen there. Basically, it gives you 4 different expressions as multiple choice answers, and it says which of these has x plus 2b as a factor. Now, there's a lot of different variations. I've seen some others that have like 3x squared instead of 2x squared, and also there were other ones that had like 14b instead of 18b, but they're all still solved the same way. Okay, so the first method for this problem, which I think is the easiest, is to notice that if x plus 2b is going to be a factor, then for all of the expressions, the other factor has to be 2x plus 9. Basically because notice to make 2x squared, which they all have the same, a term here, you have to have 2x times x. And to make 18b, if you have 2b already, that has to be multiplied by 9. All right, so now that you have this, basically what you're checking is the middle terms. And you're seeing, okay, the outer and inner, which for this factored form are going to be 9x plus 4bx. And you're comparing those to the middle terms from all of the answer choices, and you're going to see which one gives b as a positive integer constant. So for example, take the first one. Okay, we have 9x plus 4bx. If we set that equal to 9x, now we can technically ignore the x's at this part. We're only worried about the coefficients. So I'm just going to basically get rid of the x's because those don't matter. We're just worried about the numbers. Notice if you solve this, you get 4b equals 0, okay, or b equals 0. Now that's not a possible solution because it tells you b is positive and 0 is not positive. So that's how you could eliminate that. Now, let's say you check the second one, okay? So we have it now equal to 27. So now if you do that, notice you get 4b equal to 18. If you divide by 4, you're just going to get 18 over 4 or 9 halves. That's not an integer. It's 4.5. So that does not work as a solution. So now let's check the third answer choice. 36, you're going to get 27, and 27 over 4, which is going to be 6 3/4, I believe, 6.75. That is not an integer. So by process of elimination, we can see that it's going to be D. But if you just wanted to confirm and work it out, we'd start here with 45, we subtract with 36, and now notice 36 divided by 4 is 9. That is an integer, therefore D is the correct answer. Okay, so that is method 1. Now, second method would be to use Desmos and to do the following. So first, let me get rid of all this because we're pretending that, I'm solving this from the beginning. So first, you would still need to do this factoring. You would still need to determine it's going to factor as 2x plus 9, x plus 2b. All right. Then what we're going to do is we're going to go to Desmos. And now you're going to enter in the graph of the original factored expression. We're going to add a slider for b. And then I'm going to enter in all of the answer choices. And essentially what I'm going to do is I'm going to move the slider and see which, eventually I will get to a b value where one of the graphs overlaps. Now, this one I'm actually going to delete it and just do it again so I get a different color. So that way I have 4 different colors for the answer choices. Okay. So now, again, I have graphed if you zoom out here, you can see a better picture. I've graphed the original problem and I have graphed all 4 answer choices. Okay, you can see that there are 5 distinct graphs. What we're looking for is when the red one, which is the original factored form here, overlaps one of these other 4 colors, green, purple, black, or blue. Also, I'm going to change my step value to 1 since I know it has to be an integer. That way I don't have to worry about moving between all the decimals. So, and you can see here, nothing overlaps, nothing overlaps, nothing still overlaps, nothing overlaps, nope. Finally, oh, the red one disappeared. You can see the other ones are still way up here. You have to go for this specific example to b equals 9 to see that the red, the original form, and blue, answer choice D, overlap entirely. Notice how I take that off? The red one's underneath it. So this is how you could solve it entirely in Desmos. For some of the other examples, meaning for different numbers, the b value isn't quite as large. I think for some of the other ones, like the b value works out to be 5, so you don't have to go like all the way up to 9. But this is how you could do it entirely in Desmos. All right, so now let's talk about a third method. There's actually 2 methods here. One of them uses kind of Desmos and one doesn't, but they're both similar. So let's pretend, again, we're starting this problem from scratch. So notice if x plus 2b is a factor, that means, x equals negative 2b is is a root or a 0, which means when you plug this in, you expect to get 0 as your output. So if you go through and you plug in negative 2b, okay, for all the x's, notice you're going to get basically for the first thing, negative 2b squared. This whole thing is 4b squared, and this whole thing, and this becomes 8b squared. This 18b at the end, I'm just actually going to write that second because this term and this term are the same in each. It's only the middle terms that are different. So like these, I'm not going to bother, just writing them out. We just copy them down. All right, and then we have minus 18b for answer choice A. We have minus 54b for answer choice B. We have minus, let's see here, 72b for answer choice C, and we have minus 90b. Again, what I did is I said, okay, if this is a factor, that means that x equals negative 2b is a 0. Therefore, when I plug this in to the expression and evaluate it, I should expect to get 0. So now what we get, just when you simplify all these, is 8b squared, that part's the same, and then, you're going to combine the b terms here. Well, in the first one, these cancel out. In the next one, you get minus 36b. In this one, that should not be minus 7. That should be, 72b. So this one you get minus 54b, and then lastly you get minus 72b. Okay. Now, uh, what you can do is basically, what you're trying to figure out at this point is which of these, essentially their equations, has integer solution values because b has to be a positive integer constant. So you could technically do this by hand, but notice, so for the first one, b is just going to be 0. So in other words, if you set this equal to 0 and solve it, you divide by 8, and then b squared is 0, and then you square root, and b is equal to 0. Well, that doesn't work because b has to be positive. So for the next three, again, you could do them by hand, but I think it's easier just to go to Desmos. So all I'm going to do is go to Desmos. I'm not going to use b, obviously I'm going to use x, but it's like 8x squared minus 36x. Now, if you notice, okay, here are, just do it, it's easier to just do it this way. So I get two answers here. I get 0 and I get 4.5. So these are the same values for b that I was getting in method 1 when I was solving the equation. So notice they're not integers, and all of these are, by the way, all these are going to have a 0. This is going to be 4.5. If we go to, just change this up, 54. Okay, now it jumps out here. It is 6.75, 6 and 3/4. Again, just like I got doing the first method. And then the last one, notice here it gives us b equals 9, which is what I got solving it out. So therefore, answer choice D is the only one that when you plug in negative 2b, basically gives you a solution of a b value when it's set equal to 0, which is an integer. Therefore, D is going to be the correct answer. All right, so now a slight variation of this is you could go to Desmos, and what you're going to do is essentially kind of do the same thing that I was doing in method 3, except that you're going to use a slider and you're going to see which one equals 0. So here's what I mean by that. I'm going to type the first answer choice, except I'm going to replace every x with negative 2b. Okay, so here's the first thing. I've plugged in negative 2b for both the x terms, and now I add a slider for b. And essentially what I'm going to do is I'm going to move the slider, and I'm going to see, is there an integer b value which gives me 0 as my output? Because that's what should happen when you plug negative 2b into the problem. And if I go from 1 to 10, notice there aren't any, and it also keeps getting bigger. Like it's not, you know what I mean? It's not going to get smaller. And then you could change this to 27. And you could see, do we get 0? Nope. Notice it jumps there from negative 16 to positive 20, and then it keeps getting larger. And then you could do the same thing for 36 here. Okay, looks like it's coming up. Oh, it jumps from negative 36, so it doesn't actually hit 0. And then it just keeps getting larger. And now if we go to 45, we start back here at 1. Okay, starting to get to come up. Right here at b equals 9, which is not coincidentally the same value I found in the second method of solving this. Notice I get 0 as an output. That confirms that D is the correct answer. Here with question number 1. So here you have this quadratic equation with a bunch of constants in it, r and s, and also you have this constant k in the problem. So we want to know the smallest possible value of k for this question has at least basically 2 real solutions. So the traditional way that you would solve this is you would basically set up the discriminant, set it greater than or equal to 0, and then when you go ahead and rearrange that, you're going to find that you will have r over s on one side of it. So what I mean by that is, we have b squared minus 4ac. That's the discriminant. For real solutions, we want it, I guess for 2 real solutions, technically we want it to be strictly greater than 0, not equal to 0. So now if you plug in the numbers, you're going to have negative 24s for b, and then minus 4 times 6r times 6r for c. Okay, and then we simplify this out, we get 576s squared. And then for the next part, this just becomes minus 144r squared. If you go ahead and separate these, you get 576s squared greater than 144r squared. And then what you're going to do is you're going to divide both sides by 144. Okay, so if you do that, 576 divided by 144 is just going to reduce to 4 over 1. Then you're also going to divide both sides by s squared. So what you get is 4 is less than r squared over s squared. Or if you want to rearrange it, you could also say r squared over s squared less than, excuse me. This is going the wrong way. Sorry, it's this. It's 4, 4 is greater than r squared over s squared. And then if you rearrange it, it becomes r squared over s squared less than 4. Next, you would take the square root of both sides. And so technically, when you have an inequality, essentially a quadratic inequality. That's what we have here. So when you square root on the left side, okay, that just becomes r over s. Now on the right side, okay, the square root of 4 is obviously 2, but the way you actually solve this is technically 2 is your critical point. Sorry, positive 2 and negative 2, because when you take the square root, you have both plus and minus. And then what you need to do is essentially you set your critical points up on a number line, and then you go and you see like in what regions on the number line does the value exist in to make the inequality true. So what we mean by that is for r squared over s squared, okay, to be less than 4, essentially, if you take, so again, we're looking at like r over s, the whole thing is our number, right? If you say that r over s is equal to, so like this is our critical point, this is our critical point where it's equal to 0. So let's say you take like negative 3, here we could just put a 0, here we could put positive 3, right? So if you put negative 3 in for r over s, and then you square that, so you put it back into the original inequality here, right? Negative 3 squared becomes 9. So is 4 greater than 9? And the answer is no, it is not. So therefore, this region is not where the solution lies. And the same thing is going to be true in the region greater than 2. So in other words, if you let r over s be positive 3, okay? So it's like 4 greater than, r squared over s squared, which is, you could just rewrite as r over s quantity squared. So when you square that, you get, again, 4 is greater than 9. That is false. That is not true. So the solution is not out here. The solution is going to be solely this region in here. In other words, all the values between negative 2 and positive 2 are for the fraction r over s that make this solution, make this equation have 2 real solutions. So the question is, what's the smallest value, or in other words, what's really k is, think of it as k is the lower limit, or k is the floor for how low your r over s value can go. It can't equal it, it still has to be greater than it, but it's going to be right here, -2. -2 is the floor. -2 is the bottom number in the interval, such that if you plug it in, you would still have any number over -2, which is also less than +2, would give you two real solutions. Okay, so the smallest possible value for k of this is going to be -2. All right, and that's basically the final answer. Now, if that was too much work or you're too confused by it, that's fine. I will show you how to do this basically in Desmos. So what I'm going to do is just drop this down. Let me scroll down a little bit here. Okay, problem's still on the screen. First, I'm just going to type this whole thing in, except there are a couple changes we have to make. I am going to replace R with P. The reason I do that is because in Desmos, R is defined to be the radius of a circle. So we can't technically use R. If we try to use R, it'll mess up essentially the problem. It won't work out properly. So every R I replace with a P. Oh, I'm also going to get rid of the equal 0 because I really want to graph this thing and look for the solutions as x-intercept values. All right, so we've got P, we've got S here, and essentially our K value is P over S or R over S, right? So now what we can do is basically, oh, actually, sorry, one thing that we do need to notice, which is that R is positive and S is negative. Right here, R is greater than 0, S is less than 0. So when we go to do this in the problem, we actually, okay, we have to make this a negative number. All right. So if you just let t be constant, or actually, let's do it like this. Let's let S be -1. Okay. And now I'm going to move the P, which is equivalent to R, and I'm going to see essentially like what's my smallest value of K, which will still give me two real solutions. So notice as I'm increasing this, as I'm making P, i.e. R, larger, notice that that is technically making K smaller, right? It's going to -1.8, -1.9, blah, blah. Okay, and notice right here at -2, excuse me, it has one real solution. So that means, like, again, -2 is the floor. -2 is the lower limit for K. So in other words, your K value has to be greater than -2. Notice if I go this way, if I make it less than -2, it just keeps going up and up and up and up. There's no real solutions. So I have to go the other direction. Okay, right here, I am technically at a K value which is greater, or R over S or P over S, but again, think of it as R over S value, which is greater than negative uh, -2, -1.9. And notice here there are two solutions, two real solutions, which is what we want. Okay. And you could try moving this in like various directions. I mean, you can see, I mean, basically you can go down to like, 0.00001 or whatever, because R has to stay positive. But the reason that you know that the K value will be -2 exactly, okay, and not some other number, is because notice right here when I set R or P equal to 2 and S equal to -1, the K value is -2, and that's exactly one real solution because it just touches the x-axis. So that's how you know that this is the floor, this is the lower bound, and therefore this is the answer. Because anything, like even if you make this, 1.999, like you can still technically zoom in here, you know what I mean, and see that there are two real solutions. The vertex is still below the x-axis. So the reason you know it's 2 for the correct answer for k, which is here is just the ratio of p over s or r over s, is because, or sorry, not 2, -2. The reason you know it's -2 is because at that point, when k is equal to -2, you have exactly one real solution on the graph. Okay, so anything above that will give you two real solutions. All right, sorry, took a little while going through that one, but I just want to make sure that you understood the Desmos solution in addition to the solving by hand method. So for this one, again, I'm going to do this two ways. First, I'll show you how to do it by hand, and then after that, I will show you how to solve it using Desmos. So what I would do is I would recognize on the left side here, I can rewrite this as n to the 2/3 power. On the right side, this is k to the 2/5 power, just going from radical form to rational exponent form. Now, you can technically replace k with what it's equal to, which is just n to the 2a plus 1. So I'm just going to do that. So I have n to the 2a plus 1, and that whole thing is raised still to the 2/5 power. So because we're raising to a power here, we can just multiply the exponents. So really what we have is, for this whole new exponent here, the 2 is on top, just like the 2a plus 1. So it's really 4a plus 2, over 5. That's the full exponent of the n. And that's equal to n to the 2/3. Okay, so now you can just set the exponents equal. 2/3 equals 4a plus 2 over 5. You can solve this by hand if you want, cross multiply and get 10 equal 12a plus 6. And just go ahead and subtract. And you get a equals 1/3. Now you could also solve this problem entirely in Desmos, and you don't even need to set up the equations, meaning get the equation, in terms of basically one variable. So all we have to do is let's go to Desmos, and essentially I'm going to type in a system of equations. I'm going to solve it using regression. So the first equation starts with, let's see, I need a cube root of n squared. And then that is equal to, on the right side, a fifth root. So I need nth root 5k squared. Okay, now the second equation, the left side is just k, and the right side is going to be n to the 2a plus 1. Notice here it drops off when I try to type a plus, so I have to go back up in front of it to type in the rest of the exponent. All right, so notice what's happening here is it's just returning everything as 1. That doesn't help us. That's not what we're looking for. Okay, we want to solve for a, so I'm not going to fool with that. So I'm going to just set n equal to a positive constant like 1.5. All right, and now it gives me the value of a, which is basically 1/3. It's 0.3 repeating. And you notice what happens here. As I move the value of n, okay, k changes, but the value of a does not. It stays fixed. Oh, and now notice here the fraction thing is back for whatever reason when I stopped at this value. But again, notice how I move the slider. For some reason, for some values, the fraction thing's not there. I don't know why it is, but regardless, the value of a is going to be 1/3. Okay? Because notice as I'm moving the slider here, as long as I keep it positive, the value doesn't change. So that's how you could solve this problem entirely in Desmos. Question number 6. So this one, I will show you the traditional way how to solve this, but I think it is much, much easier just to use than Desmos. So I'm actually going to show the Desmos method first, and then I'll show the traditional way after that. So a lot of people got tripped up on this because when they solved it in Desmos, basically they either just typed the whole equation. Okay, so they got two answers here, 0.462 or negative 0.923.
And it says, what is the value of x is positive? Okay, so then they went and they said 13 times 0.462 plus 3. Okay, notice it's 9.006. So technically, that is what you would enter in if they did not give you any instructions about rounding, because that fills 5 decimal places right there. The 9.006. But that's not the right answer, and it's not the right answer because this is a rounded value. This is not an exact value. So here is how you have to solve it. Here's how you have to do this to get the exact value. You have to solve this equation using regression, because regression will give you the exact value and you can carry it over and plug it into the 13x plus 3 to get the exact answer, which is actually going to be 9, basically just 9.00000. So all I do is I change the x's to x1s, I change the equal sign to a tilde. Now, here is my exact value. Even though it only shows like 6 places after the decimal, it has the others stored in there. You just don't see them. So now what I would do is I would type 13, not 13x, but 13x1 plus 3. We get 9. That's the correct answer. That's how you can do this question in Desmos in, under 30 seconds. But you have to use regression to solve it. Now, one thing just to be aware of. Technically, there are two answers here. Remember, there was a positive and a negative. So, for some reason, like if it gave you the negative answer, so for example, I'm just going to put this here, and let me see. No, it still defaults to the positive. But what I was going to say is, if you need to force Desmos to give you one of the different answers, what you can do is you can put little qualifier here in a bracket like, x1 greater than 0. That doesn't change anything because we already had this. But if you wanted the negative one, you could make it less than 0. There's the other answer, and it's the exact value. Okay? So just so you know, that's how you can force it. And you don't have to use 0. You can use you can use another value, any value you want, just to like separate it on either side of what you're looking for. Okay, now I'll show you real quick. This is like the by hand method, the way that, you would probably see the explanation written out if this was in the question bank. Essentially, what they would have you do is they would have you move the 78x over, and then you're going to complete the square. Because if you notice, 169 is the square of 13. So it's like they're trying to get you to make 13x plus 3 quantity squared. So notice the square of 3 is 9. So basically you would add 9 to both sides, and then that would give you 13x plus 3, 13x plus 3. Right side you get 81. So we get 13x plus 3 quantity squared. And now you can square root both sides, and 13x plus 3 is equal to plus or minus 9, but if they tell you that the x is positive, well, then obviously it has to be the positive 9 for your answer. Okay, so correct answer is 9. This is how you do it up by hand, but I think it's much quicker, much easier just to do this in Desmos. Let's go ahead and get started on question number 1 here. This was a very common one that was mentioned a lot. Basically, you have an exponential function, and the cells are increasing by p% every 150 seconds, and they want to know which of these expressions here represents the percentage increase for this given time period. So a couple things to keep in mind. First of all, the actual function is given where m, the variable, is in minutes, but this p% increase is in seconds. So we have to convert the 150 seconds to minutes, basically just by, you're really going to be dividing by 60 if you think about it, multiplying by 60 seconds on the bottom and 1 minute on top. So if you do that, it just comes out to 2.5. Okay, so 150 seconds, same as 2.5, 2.5 minutes. All right, so with that being said, first I'll show you kind of the theoretical way to do this, and then I will show you an actual way to do it with picking numbers, which just confirms what the right answer is. So theoretical way, I would say let's start with m at m equals 0, and then let's compare that to m equals 2.5. In other words, we have our initial amount, starting amount at time t, basically like m time equals 0, and then after 150 seconds, we have some amount. We'll see how much it increases by. So if we do that and plug in 0 for m, notice you're just going to get 61 times q to the 0, but any number raised to the 0 power is just 1, so this is really just equal to 61. And then for 2.5, you're just going to get 61q to the 2.5 over 5, which you would just simplify to q to the 1/2. All right. So now remember, to find percentage increase, it's basically new minus old over old. Or you could also, instead of old, you could also think of it as the O standing for original, the original starting value. And then of course for percentage, you're going to multiply it by 100%. All right. So the new value is the 2.5 minute value, which is the 61q to the 1/2. The old value is the original value, the just 61, and then we divide by the original value, the old value, which is 61. And then, of course, times the 100%. So first of all, these all have 100 in front of them, so we can essentially ignore this. Really what we're looking at is this part right here, which of these simplifies to something that we see in the answer choices. So notice what happens is each of these has a 61 in common. So it's basically like you factor the 61 out on the top. You get q to the 1/2 minus 1. You have the 61 on bottom. These cancel out. And now, and then times the 100%, notice we have answer choice D right here. 100 times q to the 1/2 minus 1. So the correct answer for this problem is answer choice D. Now, I will just show you, you could also just confirm this or solve this in Desmos using actual numbers for Q, and then finding the percentage increase among them. So what I'm going to do is I'm going to, let's see here. Okay, so first I'm going to type the function. I'm going to let Q, what did I pick? I just let Q equal 2. Okay, and then for M, first I let that be 0 for my starting amount. Okay, so 61 is what I defined. I'm going to define that as O. 61 is my original or my old value. And now I'm going to change M to 2.5. Okay, every 150 seconds, 2.5 minutes. Okay, so now I get this value. This is what I'm going to set equal to N. So I'm going to actually do that up here. So N is equal to 86.26, blah, blah, blah. So what's the percent increase if I start at 61 and I end up at 86.267, blah, whatever? Well, it's just N minus O divided by O. And of course, now it's times, 100 to turn it into a percentage. So 41.42. All right, so now all we have to do is go through the answer choices and see which of these equals 41.42. And I can just type them in with the Q given. Okay, this first one is gigantic, so it's obviously not the correct answer. For the next one here, see, this is actually the correct answer, but really I'm supposed to be checking B next. Okay, 241.42, that's too big, that does not match. Then if you want to check C, change this back to a Q squared, now change this back to a -1. Okay, 300% increase, nope, way too big. So by process of elimination, you would recognize that it's D, but we can also see the values match, okay? So the percentage increase I get, calculating it out using just picking numbers for Q, and plugging in m equals 0 and m equals 2.5 and finding the percentage increase according to the formula matches what you get when I plug in the value of Q that I chose to the different answer choices. So correct answer is just going to be D here. Top of the next page for question number 4. Here we have one that deals with percentages, and I'm going to draw this out kind of, it's not really a Venn diagram, it's more like a tree. tree diagram to hopefully help you understand it. So, and this is basically using picking numbers. So you have this piece of land, okay, 52% of it is farmland. So I'm going to say, okay, the piece of land is 100 whatever square meters. You can use whatever unit you want. Okay, 52% of it is farmland. So that means 52, again, use whatever unit is. This is farmland, and the remaining, which would be 48%, is prairie, open prairie. Okay, now, of the farmland, 21.5% is occupied by buildings. So I'm going to split this up and basically do 21.5% of 52. All right, 11.18. So that means 11.18, again, square meters, whatever units you want to use, is buildings. And the remaining value, which technically doesn't matter, but I already did it. I think it should be, let me just check, 40.82. It's going to be first. Get rid of this. Get that out of there. 1 minus this. Parentheses, yeah, 40.82. Just 1 minus 21.5% times the 52. Okay. Now we can do the same thing for the prairie. So in the open prairie, 19% are occupied by buildings. All right. So that means 0.19 times the 48. So 9.12. Buildings, and the remaining amount, technically, it doesn't matter. There's multiple ways you could do it. The easiest way is to actually just do 48 minus that. It's going to be 38.88. All right. What percent of the overall land is occupied by buildings? So now basically what we're looking at is, okay, this and this. So because I started with 100, I can just add these two together, and that's basically my answer, because technically you're just going to add them together, but then you're going to divide by 100, which is the total, but dividing by 100 won't change the value. It just moves the decimal place over. So we've got 11.18 plus 9.12. So the correct answer, at least for these specific numbers, is going to be 20.3%. So the answer you would select or you would fill in is 20.3 since they're asking for it as a percentage. This is, I think, the easiest way to do this problem, using this idea of picking numbers, like starting with a value of 100 and breaking it down like this. You could do this again, like theoretically, using like an X and then, 100 times 0.52 and then times 0.215 and blah, blah. But I think it's just much easier to see, to visualize, understand using actual values. All right, next up, question number 5. Here you have this equation which gives the value of the partial circumference of a circle. Notice 2 pi r here is the circumference, but this is, 2/3 of it. And we want to know for a 13-inch increase in the radius, how much does this equation, or the partial circumference, increase by? Essentially, it wants to know what k is here in this expression, k pi. All right. So again, easiest way I think to do this is basically just with picking numbers. So I would start with a radius of 0, and my partial circumference value would, of course, just be 0. All right, so now if I increase the radius by 13, whatever unit we're talking about here, 13 inches, now the radius is 13. So if you plug 13 into this formula up here, 2/3 times 2 pi times 13, basically you get 13 times 2, 26, 26 times 2 is 52, you get 52 pi over 3. So the C of R value increased by this much when we increased the radius by 13 inches. Okay, Therefore, this is what's equal to k pi. So what is the value of k? Well, the pi's cancel out. K is just 52 over 52 over 3, excuse me. So you could enter it in as 52 over 3. You could also put in the decimal equivalent form of 17.33. Either of those answers would be acceptable. And you can also just confirm this using other values. Like I'll just show you quickly in Desmos. If you just define the function, I'm going to use x instead of r. So we have 2/3 times 2 pi x. Okay, so now I'm just going to use 10 and 23. All right, so I start with 10 and I get this partial circumference value. Then I go to 23. I get a partial circumference value. Now I subtract these two to find the difference. Here's the thing that's tricky. Here's what you have to be aware of. Notice in the problem, they say, like for a 13-inch increase, i.e. the difference we're finding here, it's equal to k pi. So this number is equal to k pi. That means to find k, you have to take this value and divide it by pi. So in other words, I'm going to take this, divide it by pi, and notice now it gives me the 17.33 that I had as my answer. And if you click on this, it should give us, yep, fractional form 52 over 3. Okay, so this is just how you could do it out in Desmos and just confirm using other values that, yes, for a 13-inch increase in the radius, the change in this function is equal to 52 over 3 pi. All right, the last question on this December 2024 Digital SAT Math problem set number 2. Fairly complicated question, but it's actually not that bad once you take a look at it. So essentially what's going on here, this one, I don't know if they maybe gave you the picture or they just described it, in words, but essentially what you have is you have a sphere, and this is obviously not 3D, this is just, 2D, so it's a circle, but have the sphere, and then inside the sphere you have a cone. All right. So the radius of the sphere is 35. That means all the way across here at the middle, the diameter would be 70, which means that tells you that the cone, I guess there would have to be some way to let you know whether it's above or below the, the diameter point of it. Because the way I set it up, the way I solved it was I drew the cone down here, going to the top. Okay, and then coming down, we know that the, let's see, diameter of the cone is 56. So that means all the way across here is 56, which means this is 28. All right, so they want to know, basically want to know what the volume of the cone is. So formula for volume of cone, 1/3 pi r squared h. So we need the radius of the cone. Well, that we actually already have. It's 28, but we need the height of the cone. Okay, we need this total distance right here. Now, the way we're going to find that is actually by setting up a triangle, right triangle specifically, right here from the center of the sphere. Because now we have a right triangle and we know one side is 28 and we also know this hypotenuse is 35. The reason we know it's 35 is because this is just a radius, going from here out to the edge of the sphere, that's just a radius of it. So we know the radius is half the diameter, the radius is here, they give us, it's 35. So we got 28 squared plus whatever it calls x squared equals 35 squared. This, we can just go to Desmos, we can just solve it right in there. Get rid of all this. I'm just going to use regression. Okay, so, I forgot to square it. There we go. Sorry, we want, 21. So, therefore, This distance right here is going to be 21. Now, we can add that to this distance right here, which again, this is a radius of the sphere, which is 35. That gives us the total height of the cone as 56. Therefore, the volume is going to be 1/3 times pi times 28 squared times 56. So if you go ahead and just multiply this all out, we can just do it in Desmos. It should come out to 14,634.66 pi. And the k value they're looking for here is the number that's multiplied by the pi. And it says about rounding it to the nearest whole number, so it should be 14,635. Let's just go to Desmos to confirm. Slide this up. 1/3. Okay, technically I'm just going to ignore the pi because that, we don't need that. We just need everything else besides that. All right, so yep, there we get 14,634.666, 2/3. And again, we can round that just to 14,635. So that should be the answer to this question. So just to talk about this problem now, one last thing. If you had the opposite scenario to where, like, say the cone was up here, then I'm trying to think how we would do this. I guess you would kind of do the opposite method, which would be like we know that the diameter of the cone is 28. We know this is a radius. So this would be the 21. Basically, these triangles are like mirror images of each other. And we know this whole thing is 35 because this is a radius. Therefore, this right here, this distance from here to here would be 14. So if that were the case, then everything would be the same, except now your height would be 14 instead of 56. So you'd be doing 35 minus 14 instead of previously we did, or sorry, excuse me, 35 minus 21 to get 14 instead of 35 plus 21 like we did last time. So then you could work it out and you get whatever number and you'd round that and everything. So for this problem, I guess maybe they had to give you the picture or else they had to somehow describe or basically tell you that the base of the cone is like below essentially the halfway point of the sphere, in order to know that it was set up like the first way that I did it. Go ahead and get started on problem number one that dealt with resistors in a circuit. So this circuit has 8 total resistors. I'm assuming it's a series circuit, not as compared to parallel. If you've taken physics, you would understand that. But if not, just completely ignore it. Because it tells you that the the total resistance is equal to the sum of the individual, basically, resistors, i.e. the resistance from each resistor. So there's a total resistance of 110 ohms. 3 of the resistors of the 8 have a total combined resistance of 70. So that means we've got 110 total. We take away the 70 for these 3. That means we have 40 total ohms left for 5 remaining resistors. So which of these inequalities represents, the possible values for the individual resistance of one of these 5 resistors? All right. The correct answer is going to be letter B here. First of all, the resistance for each of these individual resistors has to be positive, so it has to be, like basically the floor essentially is going to be 0. C doesn't even, make any sense because we only have 40 total ohms left to divide among 5, so it's impossible for even one of them to be more than 40, when that's all we have left. And obviously D is out because we only have 40 total ohms left, so it's impossible for any individual one to have a resistance greater than 40. And D has its upper limit or its ceiling, up at 110, anything from between 0 and 110. All right, so now if you're looking between A and B, basically there's nothing that says, that the maximum value for each remaining resistor is only 8 ohms. Or in other words, there's nothing that says that each one has to have the same amount of resistance. In other words, each like 8, 8, 8, 8, 8, or um, versus, uh, you know, 5, 5, 5, 5, 20. As long as they add up to 40 total ohms among the 5 resistors, then we would have a total resistance of 110 ohms, which meets the conditions of the problem. Okay, so anything between 0 and 40 is possible. Notice it's got to be strictly less than 40. It cannot be less than or equal to 40, because if one of them was 40, the rest would all have to be 0, and that cannot happen. But the correct answer for this one is just going to be letter B. All right, bottom of the page, problem number 3. So this is a repeat problem. This is one we've seen before. I will show you both methods that you can use to solve it. So, excuse me. What you have here is basically a polynomial function, and you have some points. And what happens is when you plug in, let's say, this first point, so we have -1 minus 3 squared minus b, and then in the second thing, same thing, -1 minus 3 squared minus c. Okay. Notice what happens is -1 minus 3 becomes -4. -4 squared becomes 16. Okay. Now, let's say I wanted to plug in 7 for x. Okay, here, because it says what's the value of f of 12 plus f of 7? So notice if you plug in 7 here, you get 7 minus 3 squared, okay, in both parentheses. What is 7 minus 3? Just 4. What is 4 squared? 16. You get the exact same answer, i.e. the same y value for f of -1 as you do for f of 7, because this polynomial happens to be symmetric. So in other words, the f of 7 value is just equal to the f of -1 value, which is 28. And the same thing is going to be true for -6 and +12. Because if you put in -6, notice it's going to be -6 minus 3 squared, -9 squared. Whereas if you put in 12, switch colors here, you get 12 minus 3 squared, which is +9 squared. They both give you 81. So the whole point is f of 12 will equal f of -6. So f of 12 will also equal 868. Therefore, you just add these two values together and you get 896, and that's the answer you fill in. And that's it. No more work is needed besides that. Now, you could also do this problem in Desmos. So here's how you would do it. What you do is you just go ahead, make a table, type in the 2 points. Even though we have 3 constants, we're actually going to be able to do a regression on this function with only 2 points. And the reason is because of the symmetry. So now I can just start filling everything in. Gonna need another parenthesis here. Minus b, close parenthesis, 2 open parentheses, x1 minus 3 squared minus c, close parenthesis. All right, so now okay, so now I went through, did a regression on the function. I have a nice graph of it. So basically, what you're going to see is, okay, when x is -1, it intersects the function up here at 28. Okay, so now let's say we wanted to find what it's equal to at 7. Notice again, it's symmetric right here. F of 7 is 28. So you could just get it from that way, and then you could do the same thing with 12. Now the problem is, it's way up here. You got to zoom out, and then it's like kind of difficult to see where it intersects it at. You can find it eventually, but if you wanted to, you could also just retype the function like f of x equals a parentheses x minus 3 squared minus b, x minus 3 squared minus c. Okay, it's going to carry the a, b, and c values all over, and then you could just do f of 12 plus f of 7. 896, that's our answer. Okay, so that's how you could do this entire problem in Desmos. Here you have a problem where you're given two cylinders that are similar. You're given the volume of each of them, and you're given the radius of one of them. And the question's asking for basically the difference in the surface area between the two cylinders. And notice it's framed as positive difference because it wants you to subtract the larger surface area minus the smaller one. Okay, so first thing I would do is I would take the volume of B and divide it by the volume of A. That will give us the what I call the volume factor. All right, so if we do that, obviously the pi's cancel out, and you should get 27. All right, that means that the scale factor, let me just confirm here in Desmos. Yes, okay, so we get 27. So that's the volume factor, and the volume factor is the cube of the scale factor. Or an alternate way to think of that is the scale factor is the cube root of the volume factor. So the volume factor is 27. That means the scale factor, i.e., how much each individual side or, distance is for one versus the other is going to be 3. Cube root of 27 is just 3. So this means the radius of B is 3 times the radius of A. The height of B is 3 times the height of A. So we can use that to now figure out that I'm just going to put A and B here. Okay, and we'll put radius and height. So we know the radius of A is 9, that's given. Therefore, the radius of B is 3 times that, it's got to be 27. Okay, next we can figure out the height of cylinder A. So what we can do is we can take the volume, which is 567 pi, and set that equal to the formula for volume, which is pi r squared h, or pi r squared times the height. Fill in the radius value. Height value is what we're going to solve for. Okay, 9 squared is 81. The pi's will cancel out. Basically, you're dividing both sides by pi, and then just divide this by 81. You should get for your height 7. Let's just go to Desmos to check that. Okay, good. Height is 7. All right, so now I can just fill in my little chart here. That means the height for radius B is actually going to be 21. Now, we can calculate the surface area for cylinder A. So they give you the formula here. This is the surface area of a cylinder is not one of the provided formulas on the test. So just be aware. Not sure if it's provided in problems on the test because we don't have the official exams to look at. So I provided it here, but otherwise definitely make sure that you have it memorized. So we get 2 pi times 9 squared plus 2 pi times 9 times 7. So if we work that out, that should come out to 288 pi. Let's just go to Desmos to check it. Note, I'm going to skip just skip all the pi's. I just want the coefficient, the number in front of it. So I'm just going to leave the pi out, put everything else in. Okay, good. So surface area of A is 288 pi. Now, you technically don't actually need to calculate the surface area of B. You actually don't even need to figure out the height of B either. A little shortcut that you can use to save time is that the area factor, which is related to the volume factor and the scale factor, okay, the area factor is just the square of the scale factor. So the scale factor is 3, therefore the area factor is going to be 9. So I can just tell you that the surface area of cylinder B is going to be 288 times 9. 2592 pi. Now, if you didn't know that, or if you just want to calculate the surface area of cylinder B, completely on your own, like that's fine as well. So let's just go ahead and do that just to confirm, that's what we get. So surface area B is going to be 2 pi times 27 squared plus 2 pi times 27 times 21. So I'll just go to Desmos again. All I have to do is replace the 9 with a 27 and the 7 with a 21. 2592, I get the same answer. Okay, just confirms that it is correct. All right. So again, that's just a little shortcut you could use if you want to save time, want to skip some work. Now we can do the final step. It's 2592 pi minus 288 pi. We don't care about the pi part. We're only cared about the subtracting the coefficients here. So we can go ahead and do that. 2304 pi is what you get for the positive difference in the surface area, but we only want the number in front of the pi. So 2304 is the answer you're going to fill in for this problem. Okay, next one up, question number 8. So what I'm going to do for this one, where you have a quadratic equation, basically they tell you it's factorable. That's what this whole px plus q thing is. And basically it's got the b value already filled in as 196. They want to know what's the largest possible value of AC. So the traditional way to do this, the by hand way to do this, is to take your discriminant, your b squared minus 4ac, set that greater than or equal to 0, and then plug in 196 for b. A and c, just put a and c in, and go ahead and solve this inequality. So what you end up doing is you just get 196 squared, 38,416 greater than or equal to 4ac, divide by 4. AC should be less than equal to 9604. So that should be your answer. Again, we'll just double check here. It's 196 squared, and then that value gets divided by 4. So we should get 9604 as the answer. Now, you could do this problem in Desmos, but I think it would be probably time prohibitive in that, basically you would enter the, I guess not the full equation, but you would enter just the function, whatever set it equal to y, add some sliders. Now, you could set C to whatever, you could get, set A to whatever, and then down here you have like your AC value, right? So what you're looking for is, and it's kind of difficult to see here, like eventually you want, I'm just gonna like jump these up here. There to be no x intercepts. So, okay, see right here, I'm at 9,500. And then if I go here, okay, see like right now I got my AC value 9,600, and see it's just below the x-axis. So the largest possible value is going to be the largest A and C values, such that you have at least one solution or one x-intercept. So like right here, 9610, it's already over. So it's something obviously less than 9610, but more than 9600. And then you could try this, 9601, 9602, 9603, 9604. Okay, notice right here it's on the axis, so there still is one solution. Okay, but now 9605 is too high. basically it's not a possible value of AC because there are no real solutions, which would mean that the expression's not factorable, which it is. So you could do this using sliders in Desmos, but because the numbers are so big and you'd have to like constantly scroll and you know what I mean, like keep making them larger and larger, I probably would not recommend that way. I mean, you can absolutely use it to check and confirm that your answer is correct, which I just did, knowing it was 964 already. But if you're just trying to like, figure it out on your own, I probably would not recommend that method.
One last thing to mention, if you're looking to improve your knowledge of Desmos, then please check out my Ultimate Desmos Guide to Digital SAT Math. There are two versions of it now. There's the free version, which is on my YouTube channel. Currently has over 70 practice problems. Covers all the various topics from your basic core skills up through advanced topics and the various types of regression that you can use to solve constants in the various problems you find at the end of Module 2. And then there's now also a premium version that you can purchase on Udemy. The material in both of the courses is essentially the same. The main advantages to the premium version are that it's ad-free. In other words, you don't have to bother watching ads like you would on YouTube. And I've re-recorded some sections of it and basically rearranged them, especially the advanced skills, so that the common types of problems that have multiple methods are all grouped together. So in other words, all the different methods you can use to solve for a constant in a system of linear equations are all together in one video. And all the different types of methods you can use for solving to find the value of a constant for various types of quadratic problems, are all basically grouped together in one method. So it's organized a little bit better than compared to the original, free version on YouTube, where the problems and the topics that are covered in it are basically just, chronological as I, figure them out or discover them. So in either case, please check out either of those. They're loaded with tips and tricks and basically all the practice problems and skills that you need to ace the digital SAT math section using Desmos.